how many complete oscillations, or how many oscillations are we going to have, and that will be our frequency. So we are going to have 3 times 1 divided by 7.0 times 10 power negative 3. So we can calculate this using your calculator. So we are going to have 3 divided by 7 times 10 power negative 3. So what do you end up getting? So we can write it to 2 decimal places. So we are going to have 428.57. And this is frequency, so it is 428.57 hertz. So that is what we are going to have for that, 428.57 hertz. So because the number of complete oscillations here are 3 in 7.0 times 10 power negative 3 seconds. So in 1 second, we want to know the oscillations. There will be 428.57 hertz. So that will be our frequency. How are you, my student? My name is Purity Anzelimo, and I am teaching you physics. And our today's lesson is, our topic is linear motion. Linear motion. That is what we are going to cover today, the linear motion. And by the end of this lesson, this is the following that you should be able to do by the end of the lesson. These are the lesson objectives. The lesson objectives. Number 1, you should be able to define linear motion. Define linear motion. That is 1. You'll be in a position to define what linear motion is. Then number 2, you'll also be in a position to state other 2 common types of motion. Common types of motion, because we have other types of motion other than the linear motion. Then number 3, you'll also be in a position to define the terms. You'll be able to define these terms. 1, we'll be able to define distance. Then number 2, displacement. And thirdly, you'll also be in a position to define speed. So this is what we are going to cover in this lesson. We'll be able to define the linear motion, state 2 other common types of motion, then also define the following terms. That is distance, we'll also have displacement, and we also have speed. So I want us to start with the definition of linear motion. When we talk of linear motion simply refers to motion in a straight line. Linear motion. From this word linear, we have line. So the word linear comes from the word line. And therefore, when again we talk of motion, we mean that the body is not stationary, but it is moving. A body that is moving. So when we talk of linear motion, it simply refers to motion in a straight line. Motion in a straight line. So motion in a straight line is simply what we refer to as linear motion. Motion in a straight line. And this type of motion has another name. It is also referred to as translational motion. Also referred to as the translational motion. It is also referred to as translational motion. Linear motion, another name for linear motion is the translational motion, and it is the motion in a straight line. That's what we refer to as the linear motion. Then we have other types of motion. We also have other types of motion. types of motion other than the linear motion, that is motion in a straight line. We have number one, what we call the circular motion. Circular motion. Circular motion is also referred to as the rotational motion. The rotational or the circular motion, which we are going to cover in another topic. It is a broad topic. Then again we have another type of motion which we call the vibrational motion, also referred to as the oscillatory motion. Oscillatory motion. So we have these other common types of motion, that is the circular or the rotational motion. We also have the vibrational or the oscillatory motion. We are going to cover them in other topics. So these are the other types of motion, and they are commonly used: the linear motion, the oscillatory motion, and also the rotational motion. Now, the study of motion of bodies or the motion of objects is also divided. That study of motion is divided into two main branches. So the study of motion of object, study of motion of the objects is largely divided into two main branches. Is divided into two main branches. That is the study of motion, and these ones are: number one, we have what we call kinematics, and we also have what we call dynamics. We have these two branches of the study of motion. It is largely divided into two. Number one, we have what we call kinematics, and we also have what we call dynamics. When we talk of, if we start with the kinematics refers to the study of motion of bodies, simply the study of motion of bodies. And in this concept, in this study, the forces that are causing the motion are disregarded. Remember, in another topic, we were looking at the force, and we were looking at some of the effects of force on a body. And one of the effects of force on a body is that it makes a stationary body move. And therefore now in kinematics, we just study the motion of a body, but we disregard the forces that influence that motion. So in kinematics, we have the study of motion of bodies. And here we are saying that the forces causing the motion are disregarded. They are disregarded. So we do not mention them in this. They are disregarded. That is for kinematics. So we want to define dynamics. We've already defined what kinematics is all about. So we move ahead and define dynamics. So the other branch is dynamics. That's the number two. So in dynamics, here we study the motion of a body, and also the forces that influence the motion are also considered. So here we regard both the motion and also the forces that influence, because we have various types of forces, and these forces influence the motion of a body. So here we study, in dynamics, there is the study of motion of bodies, study of motion of bodies, and the forces that influence the motion, and the forces that influence the motion. So we study both the motion and also the forces that influence the motion. So you can see the two branches. For the kinematics, we only study the motion of bodies, but in dynamics, we study both the motion of the bodies and the forces that influence the motion. Those are the two main branches of the study of motion, because we have seen that the study of motion is divided into two main branches. Now I want us to move ahead and look at the definition of terms. the definition of terms. Definition of terms in this topic. These are the terms that we are going to use in this topic. So the terms that we are going to define, number one, we are going to define distance and also be in a position to calculate. Then number two, we'll also be in a position, before speed, we'll look at displacement. We'll define displacement. Displacement. We shall also look at speed. We shall also look at velocity. We shall also look at acceleration. Acceleration. These are the terms that we are going to define: distance, displacement, speed, velocity, and acceleration. So for this lesson, we'll define distance, we'll also define displacement, and we'll also define speed, and also be in a position to do the calculations involving the same. In other books, you have covered about length and time, and all these terms that we have, we are going to derive them from length and time. So I want us to start with the first one, that is distance. Distance is one of the terms that we are going to use in this topic. So distance. Distance. When we talk of distance, distance simply refers to length between 2 points. The length between 2 points. Distance is simply length between 2 points. Length between 2 points. This is what we mean if we have a point A here and a point B here. The length from point A to point B is what we are referring to as distance. So distance is the length between 2 points. And the SI unit of distance, the SI unit of distance is meter. The SI unit of distance is meter, which is abbreviated as a small letter m. That is the symbol for the SI unit. And remember, you talked of the SI unit. This is an international system of units. This is a unit. When we talk of the SI unit, it is a unit that has been agreed internationally, whereby, for example, when you talk of meter, that is m. It is a unit that it is known, it is the unit for distance. So it is an agreed system of naming called the international system, the units. The international system, the units. The units. That is the SI units. The SI unit. So the SI unit of distance, the SI unit of distance. Remember this, the SI unit of distance is meter. And we have seen that it is abbreviated as a small letter m and not capital. Then when we talk of distance, distance only shows the magnitude or the size, but it does not show the direction. And therefore, distance is a scalar quantity. Distance is a scalar quantity. Distance is a scalar quantity. Distance is a scalar quantity, meaning that it only shows the size. And another name for size is magnitude. It only shows the size or the magnitude, but lacks direction. So when we are giving a quantity, that is the distance. For example, we'll only talk of 2 meters, we talk of 3 meters, we talk of 0.3 meters, and so on. But we do not specify the direction, because we have seen that it is a scalar quantity, and therefore it will only show the size or the magnitude. And therefore, when we are writing the distance, we only write the unit, we write the value and the unit. The value and the unit with no direction, because it is a scalar quantity. That is distance. Then we move ahead to displacement. which is our second term that you are going to define. So we have displacement. Now displacement is denoted by a symbol, that is a letter S, small letter S. It is denoted by a small letter S. So we can write it even here, S. It is denoted by a small letter S. When we talk of displacement, it simply refers to distance in a specified direction. It is distance, but now in a specified direction. It is therefore distance in a specified direction. It is distance in a specified direction. For example, we can talk of 3 meters due north. 3 meters due north. So here we have the distance and we also have the direction. And therefore this shows the size and then this shows the direction. And therefore we say displacement is a vector quantity because it shows both the size and the direction. So displacement is a vector quantity. Displacement is a vector quantity, meaning that it shows both size, which is the same as magnitude, size and direction. It shows both the size and direction. That is what we refer to as displacement. Distance in a specified direction, and we are saying that therefore it will be specified by the value comprising of the unit, for example the 3 meters. Then we also have the direction, 3 meters due north, and therefore displacement is a vector quantity, meaning that it shows both the size and also the direction. Now I can give you an example to be able to differentiate between the two, that is the distance and displacement. And I want you to consider this. Consider if a body moves. If we have a body, if a body moves due east, if a body moves due east, followed by a movement, due north, This is what we are going to have for a body moving due east, followed by a movement due north. So we have a body moving due east. Let's say we have our body here moving due east. Let's say we have the starting point here, A. Then we have the point here, B. It moves due east. Then again followed by movement due north. So we are going to have it this way. Due north. Let's say this is our point C. So there is followed by a movement due north. So this is the body moving due east and again due north. So if we have to find now the distance for this, the distance right angled. So we'll have the distance moved by this body from A to B, then from B to C. So we are going to have the distance as the length from this to this, that is A and P, then plus the distance from B to C, that is BC. Then when we want to calculate now, when we want to get the displacement, it will simply be direct from A directly to C. From A directly to C. So this is what we are going to have from A to C. So the movement is from A directly to C. And therefore our displacement, the displacement therefore will be equal to AC, A direct to C. So you can get the difference here. If a body is moving due east followed by a movement due north, then we are going to have the distance from A to B, then from B to C, that is the distance. Then we have the displacement from A directly to C, that is our displacement. So that is displacement, and I want us to move on to our next term, that is speed. Our next term is speed. Speed is the next term. Speed, then we learn how to calculate the speed. So we have speed, and I want to define what speed is all about. When we talk of speed, speed refers to distance moved per unit time, the distance covered per unit time. Speed is the distance covered per unit time. When you hear of the word per, it simply means we are dividing. So when we have speed therefore will be equal to distance covered, the distance covered per unit time, so divided by the time taken. Distance covered per unit time, this one gives us the speed. That's how we define speed, distance covered per unit time. And therefore, from this formula, whereby we are saying that speed is distance covered per unit time, we know that the SI unit of distance is meters, and the SI unit of time is seconds. And therefore, the SI unit of speed is meter per second, is therefore meter per second, or meters per second. Meters per second, which we write as meters per second this way, or you can write it this way, it simply means the same. So the SI unit of speed is meters per second. But again, we have another unit. Speed also can be expressed in kilometers per hour. It is another unit, but it is not the SI unit. Just like we have length, length, the SI unit of length is meters, but again we have other units. For example, the kilometers, the hectometers, we have the millimeters, the micrometers. All those can also be used to represent length, but the SI unit is meters. Therefore, also for speed, another unit, speed can also be expressed. Speed can also be expressed in kilometer per hour. The kilometer per hour, which we write as kilometer per hour, or simply the kilometer per hour. So it can also be expressed into kilometers per hour. Now with speed, we are saying that it is the distance covered per unit time. And therefore also speed is a scalar quantity. Distance is a scalar quantity, time is a scalar quantity. A scalar quantity divided by a scalar quantity gives a scalar quantity. When you have a scalar quantity, scalar divided by scalar, it gives you a scalar quantity again. And therefore, speed is a scalar quantity. Speed is a scalar quantity, meaning that it will only show the magnitude or the size, but it lacks direction. Now, we have seen that speed is distance covered per time, per unit time. And this one will only apply for a body that is moving with uniform speed. This is for a body moving uniformly, but if that is not the case, if the body is not moving at a uniform speed, therefore we come and calculate the average speed. The average speed, which is given by the total distance covered, divided by the total time taken. Total time taken. So if it is not moving at uniform speed, we have now the average speed, we have to calculate the average speed given by the total distance covered divided by the total time taken. For example, if we have a body or an object, let's say this object is moving from point P to point Q, and the distance from point P to point Q, let's say it's 2 meters, then it takes some rest. On reaching at point Q, it takes some rest, and it takes rest, let's say, for 2 seconds. And to move from P to Q, let's say it took 10 seconds. Then again, it continues with the journey from now the Q, it continues up to R. And let's say that this distance is 1 meter and it takes 6 seconds. Therefore, when we are calculating the average speed for this journey, the average speed will simply be equal to the total distance. The total distance whereby we have 2 meters, we also have 1 meter. Then we divide by the total time taken, whereby we have 10 seconds. We also have the 2 seconds for resting, and we also have the 6 seconds. So this one will give us the average speed, which is the total distance covered divided by the total time taken. So I want us to move ahead and now be in a position to convert the meters per second to kilometers per hour and vice versa. So we look at conversion from meters per second to kilometers per hour and vice versa. The reason why we are doing this is because some questions may ask us to convert. We may be given a question and the only option is to convert maybe kilometers per hour into meters per second or vice versa. So I want us to learn some methods that we can use to convert the meters per second to kilometers per hour and vice versa. And this I'll start by giving an example for you to understand better. Then maybe I'm also going to explain another way that also you can use. So I'm going to give an example to explain this. Example, you can be told to express 18 kilometers per hour, 2 meters per second. Express 18 kilometers per hour to meters per second. Now, when we talk of 18 kilometers per hour, this simply means it is 18 kilometers divided by 1 hour. In 1 hour. So it is 18 kilometers per hour. So when we are told now to convert it into meters per second, the first thing we need to convert kilometers to meters first. Kilometers to meters. And we know very well that 1,000 meters is an equivalent of 1 kilometer. So we come and convert the 18 kilometers into meters. So we are going to have, what about the 18 kilometers? How many meters do we have? So we cross multiply this. We are going to have 1,000 meters multiplied by 18 kilometers. We divide by 1 kilometer. These kilometers will cancel, so we get 18,000 meters. So we have the 18,000 meters. Then we move ahead and convert the hours into seconds, because we want to convert kilometers per hour to meters per second. And again, we know very well that 3,600 seconds is an equivalent of 1 hour. So what about in 1 hour, therefore, we have 3,600 seconds. And therefore, when we are converting, we have, therefore, 18,000 meters, 18,000 meters, and we have in or per 18,000 meters per 3,600 seconds. And therefore, we are going to have 18,000 meters per means we are dividing by 3,600 seconds. So when you divide this 18,000 divided by 3,600, we are going to have 180 divided by 36. 180 divided by 36, we have 5. So we end up getting 5 meters per second. So we have converted the 18 kilometers per hour into meters per second. So these are the steps. You need to convert the 18 kilometers to meters. Then you convert the hour to seconds. Then I want to do another example where we are now converting the meters per second into kilometers per hour. From meters per second to kilometers per hour. Express number 2. Express. We have 30 meters per second to kilometers per hour. The procedure is still the same, whereby we have the 30 meters per second. So therefore it means that it is 30 meters. We are dividing by 1 second. So we need to convert the meters to kilometers. Then we convert the seconds to hours. Again, we follow the same, whereby we have 1,000 meters is an equivalent of 1 kilometer. So what about the 30 meters? We cross multiply this. We are going to have 30 meters multiplied by 1 kilometer. We divide by 1,000 meters. So we are going to have, therefore, the meters will cancel, this and that will cancel. So we are going to have 3 all over 100 kilometers. Those are the kilometers that we have. Then we convert the seconds. We convert the seconds to hours. So we have 3,600 seconds being an equivalent of 1 hour. So what about 1 second? Will be an equivalent of how many hours? We cross multiply. We have 1 second times 1 hour all over 3,600 seconds. So we cancel the seconds. So we are going to have it as 1 over 3,600 hours. So now we want to express the kilometers, the meters per second into kilometers per hour. So we have it this way, the 3 all over 100 kilometers per 1 over 3,600 hours. So that is what we have, 3 over 100 kilometers per 1 over 3,600 hours. And as I've told you, that one per simply stands for division. So we are dividing. So we are going to have, therefore, 3 all over 100 kilometers. We are dividing by, we divide this one by 1 over 3,600 hours. So we are going to have 3 all over 100 times 3,600 all over 1, whereby we cancel this. 36 times 3 is 108 kilometers per hour. So we have expressed the 30 meters per second to kilometers per hour. One, we need to change the 30 meters into kilometers. Then we change the seconds into hours. And then we have, therefore, 3 all over 100 kilometers per 1 over 3,600 hours. So we divide 3 over 100 kilometers per division 1 over 3,600 hours, and we end up getting 108 kilometers per hour. So that's how we can convert. That's one way of converting the kilometers per hour into meters per second and vice versa. Alternatively, or another method, alternatively, we can have this. If we want to convert, converting kilometers per hour to meters per second, we simply look at this. We have kilometers, these are meters. When converting kilometers into meters, we multiply by 1,000. So we are going to have 1,000, and then we know that 600 seconds make an hour, so we divide by 3,600. So we multiply the value, by 1,000 all over 3,600. And this one can be written in a simpler form. that is 1000 over 3600. We can write it in a simpler form, whereby we have 1000 divided by 3600. We have this 5, this is 18. So we multiply the value by the value given, that is the value given by 5 over 18. So to convert kilometers per hour to meters per second, you can multiply the value given by 5 over 18. Like the example that we had, that is converting the kilometers per hour, that was 18 kilometers per hour to meters per second. We just come and say therefore 18 multiplied by 5 over 18, and we end up getting 5 meters per second. The same way, the same answer that we got with the other method. Again, now converting meters per second to kilometers per hour. Again, we can ask ourselves, when we are converting meters to kilometers, we come and divide by 1000. And then we know that 3600 seconds make 1 hour. So we can also therefore multiply. If we want to convert from meters per second to kilometers per hour, we multiply the value given by 3600 all over 1000. All this value is an equivalent of, if you divide this, it is an equivalent of the reciprocal of 5 over 18, which is 18 over 5. This is 18 over 5 is simpler way of writing that 600 all over 1000. And therefore, again, if we consider the other example that we had, of converting meters per second to kilometers per hour, we had 30 meters per second to kilometers per hour. So we simply need to take 30, we multiply by the 18 all over 5. And we end up getting 30 times 18 over 5 by 5, 1 by 5, 6. 6 times 18, you get 108 kilometers per hour. So those are two different methods of converting kilometers per hour into meters per second and vice versa. So you can choose which one best fits you. I want to give you the last example in this, that is for the calculations involving the terms that I've already defined. That was the distance, the displacement, and also the speed. So I want us to do another example, example 2. Example 2, whereby we are told calculate the distance in meters. Calculate the distance in meters covered by a body moving with a uniform speed of 180 kilometers per hour in 30 seconds. So I want us to do that question. Calculate the distance in meters covered by a body moving with a uniform speed of 180 kilometers per hour in 30 seconds. So we first need to analyze the values given, the quantities given, and the one that is in question. So we have the distance. We are told to calculate the distance. So what is in question is the distance, and we want the distance in meters. By a body moving with a uniform speed, we already have the speed, and the speed is 180 kilometers per hour. Then we have the time. The time taken for this is 30 seconds. And we know very well from the definition of speed, we can simply come and say speed is distance covered per unit time. So we have distance all over the time taken. And therefore from this we can make distance the subject of the formula, whereby we just need to come and cross multiply. So we are going to have distance times 1 because this speed is over 1. So we are going to have therefore distance, a number times or a value times 1 is equal to the same value. So we have distance will be equal therefore to speed multiplied by time. Speed multiplied by time, and therefore we'll have our distance. We'll have our distance, therefore distance will be equal to speed. Our speed is 180 kilometers per hour and our time is 30 seconds. And we are going to give our answer in meters. And if you look at this, here we have hours and we have seconds. So we need to change, and here we have kilometers. So for us to get our answer in meters, we need to convert to express, we need to express the 180 kilometers per hour to meters per second. We can use any of the two methods. So we can just say 180 kilometers per hour. So these 180 kilometers is an equivalent of 180 times 1,000. These are meters. And then we convert the hours into seconds. So we have per 3,600 seconds. And therefore we'll have 180,000 meters. We divide by 3,600 seconds. And we end up getting 18,000. We are dividing by 3,600. We end up getting 5. We get 5 meters per second. We have the 5 meters per second. That is 180,000. Sorry, it is 180,000. So this will be 50 meters per second. Then we continue and calculate the distance. Therefore, the distance will be equal to speed, which is 50 meters per second. We multiply by the time, which is 30 seconds. So we have 50 meters per second simply means divide by seconds. We multiply by 30 seconds. So the seconds will cancel. So we are going to have 5 times 3, which is 15. Then we add the 2 zeros. So we get 1,500 meters. And therefore, this will be the distance covered in meters by a body moving with a uniform speed of 180 kilometers per hour and in 30 seconds. That will give us the distance. So that's the distance. Now I'd like to give you an exercise that ensure that you do it to make sure that you have understood what we've covered today. So question number 1A, we have express 216 kilometers per hour in meters per second. B, 1.8 times 10 power 5 kilometers per hour in meters per second. Express the following in meters per second. A, 216 kilometers per hour. B, 1.8 times 10 power 5 kilometers per hour. Then number 2, express each of the following in kilometers per hour. A, 60 meters per second. B, 3 times 10 power 8 meters per second. Question number 3. A car on a straight road moves with a speed of 108 kilometers per hour for 30 minutes, then climbs an escarpment with a speed of 60 kilometers per hour for another 30 minutes. Determine the average speed of the car in meters per second. And lastly, the last question. A body covers a distance of 10 meters in 4 seconds. It rests for 10 seconds and finally covers a distance of 90 meters in 6 seconds. Calculate its average speed. So ensure that you are done with that work. Thank you for for being a good student. Let's meet next time.
Welcome to Manifested Publishers.
Hi learners, I am so delighted to have you again on this platform. Remember that you are still tuned into Manifested e-learning platform. I am Teacher Purity. So we are going to learn hygiene and nutrition activities. We are still learning the topic personal hygiene, and under personal hygiene, we are going to learn how to make personal items. Now, during our last lesson, we were discussing about some of the personal items we have. So let's quickly remind ourselves. Personal items are the things we do not share. So personal items are the things that we do not share, the things that you are not supposed to share with anyone. Sharing of personal items can make us fall sick. So sharing of personal items can make us fall sick. Sharing of personal items can make us fall sick. That is why you are not supposed to share your personal items. Now, the examples of personal items. Examples of personal items. We have a handkerchief, a handkerchief is a personal item, and we use a handkerchief to wipe our nose. So you are not supposed to share your handkerchief with any other person because you can contract diseases. Then we also have toothbrush. A toothbrush is a personal item. You are supposed to have your own toothbrush. Sharing of toothbrushes can make us contract diseases. Then we have underwear or pants. Underwear or pants. They are also personal items. You are not supposed to share your underwears or your pants with anyone. Then we have comb. A comb. Now we use a comb to make our hair. You are not supposed to share your comb. Why are you not supposed to share your comb? Because when you use your comb with another person, you can fall sick and you can even suffer from ringworms. Ringworms are some wounds that are always found transmitted through combs. So when you have your own personal comb, you will have protected yourself from ringworms. Then we have another personal item, have a towel. Now a towel is used to wipe our bodies after taking our bath. So you are also not supposed to share your towel. Make sure that you have your own towel. We also have another personal items. We have socks. Socks is also a personal item. Then we also have a nail cutter. A nail cutter. A nail cutter is used to trim our long nails. Remember that your nails are supposed to be short and clean. And for you to maintain short nails, you are supposed to use a nail cutter. So do not share your nail cutter with a person. Make sure that you have your own nail cutter. So these are examples of personal item. We have a handkerchief, a toothbrush, underwear or pants, comb, towel, socks, and lastly, nail cutter. So for this lesson, I want us to discuss on how to make personal items. All these items here, there are some of the items that you can still make them. It is not a must for you to buy a handkerchief. You can still get something else and use it as a handkerchief. Not a must for you to buy a toothbrush. There is something else you can use instead of a toothbrush. The same to towel. So let's see, how can we make a toothbrush? How can you make a handkerchief from what we have around us? So how to make personal item? Let's see on how to make a toothbrush. You can make a toothbrush from a chewed stick. So the first one, we can make a toothbrush from a chewed stick. Now, we can make a toothbrush from a chewed stick. If you cannot be able to afford a toothbrush, do not stop brushing your teeth because you don't have a toothbrush. You can still brush your teeth with a chewed stick. You go and get a chewed stick from as a branch of a tree, then you chew the upper part and make a toothbrush out of the chewed stick. So it can still help you to brush your teeth. We can also make a handkerchief from a piece of cloth. So we can make a handkerchief from an old piece of cloth. So we can make a handkerchief from an old piece of cloth. You go and take an old piece of cloth, wash the piece of cloth, let it dry, then you cut a piece of it and use it as your handkerchief. We can also make a face towel from an old piece of cloth. We can also make a face towel from an old piece of cloth. Remember, a face towel is used to dry our face after you have washed it. So if you cannot afford a face towel, you can as well as use an old piece of cloth to wipe your face, and make sure that the old piece of cloth is clean. So this is how we can make personal items from what we have around us. Number one, You can make a toothbrush from a chewed stick. You go and get a tree branch, a small one, then you chew it and use it as your toothbrush. The second one, we can make a handkerchief from an old piece of cloth. It is not a must for you to go to the shop and buy a handkerchief. You can as well as use an old piece of cloth and make sure that it is clean. And lastly, we can make a face towel from an old piece of cloth. So this is how we can make personal items. And remember, if you have your chewed stick as your toothbrush, you are having your old piece of cloth as your handkerchief or your face towel, you are still not supposed to share it. It is still your personal item. So make sure that you are not sharing it. You know why you are not supposed to share personal items, right? Now these are some of the ways how you can make improvised materials as personal items. So try to use them, try to use some of these improvised materials back at home. You can use a chewed stick. You have the experience of how you can brush your teeth with a chewed stick. Use a piece of cloth as your handkerchief or as your face towel. So that is all for this lesson. I want us to copy some questions and make sure that you are answering them. So the questions are here, number 1 up to 3. The instructions, write true or false to answer the following questions. So you are going to write for me in the blank spaces whether it is true or false. Number 1, we can use an old piece of cloth to wipe our nose. Write for me if it is true or false. Number 2, a chewed stick is a personal item. True or false? You write for me the answer there. And lastly, a face towel cannot be made from an old piece of cloth. You write for me the correct answer there. So finish the work and make sure that you are going through your work after you have answered it. Hope to see you in the next lesson. I have been Teacher Purity.
Hello viewers, my name is Geoffrey Omondi. We had a class of probability the last time and we talked about combined events. Now we had agreed earlier that there are mutually exclusive combined events and we still also have what we call independent events. Now today I want us to continue and still look at the events. Now we agreed in the first instance that when we are dealing with the events, the most important thing is to be able to come up with what we call a sample space, which was to tell us actually the total number of expected outcomes. Now, in today's class, I want us to look at another way in which we can come up with what we call a sample space. Now, that other way we are talking of today is what we are calling tree diagram. So in this class, I want us to actually look at what we call the tree diagram. So we're talking of probability, that is our topic. And we are saying that we can have a sample space. And the sample space, we had agreed we can represent it first of all by using columns or rectangles that can show us the total number of outcomes, but we can also use what we are calling a tree diagram. So today I want us to look at what we call a tree diagram. Now, consider. I want us to start from that point. Consider two coins tossed one after the other. after the other. So I want us to come up with a sample space of 2 coins tossed one after the other. So we can create this way and say we have the first coin. And at the same time, we can say that we have the second coin. Now, the first coin can give us only 2 responses, either a head or a tail. The second coin can only give us only 2 possible outcomes, either a head or a tail. So working with this, we can draw a sample space this way and say that the first coin can give us a head, followed by the second coin also giving us a head, or the first coin can give us a tail, followed by the second tossing giving us a head, or the first toss of the coin can give us a head, followed by the second coin or the second toss giving us a tail, or the first toss, let me just say the first coin toss so that most of us can visualize. The first coin toss can still give us a tail, and the second toss give us also a tail. So looking at this, viewers, we can therefore say that our possible outcomes are now these. We can have head for the first, followed by head again, or we can have tail followed by head, or we can have head followed by tail, or we can have tail followed by tail. So this is what we actually refer to as a sample space, or what we also call, if we want, a probability space. So we are talking of a sample space or a probability space. We can get it this way. But we are saying that we can also get this by using another method. We can also get this by using another method, which we are also referring to as the tree diagram. So let's consider the same statement, 2 coins tossed one after the other. So looking at that, 2 coins tossed one after the other, we can look at it that way and say that in the first toss, there can be a head or a tail like that. Second toss, if you had a head in the first toss, you can still get a head or a tail. But in your first toss, probably you had a tail. So if you had a tail in the first toss, you can still have a head in the second toss or a tail in the second toss. So this will be first toss, second toss. So this will be first toss, this will be second toss. So those are the toss. Now, looking at this, we can now have several outcomes. Let's look at our outcomes. So our outcomes, first of all, there can be either a head and a head, which will be HH, or another possible outcome, if we had a head in the first place, we can follow it by a tail. So that will be head, tail. Or if we had a tail in the first row, we can now have a tail followed by a head like that. Or we can have a tail followed by a tail. So in that instance, these become our outcomes. Those become our outcomes. So we can therefore say that the possible outcomes in that case is the first one there, head, head, or followed by head, tail, or followed by tail, head, or followed lastly by tail, tail. So these are our possible outcomes. Now you can see that I've had similar outcomes in both instances. Using outcomes, getting outcomes, using these branches the way I've done. These ones resembling branches, they resemble branch of a tree. This is what we are referring to as a tree diagram. So what I've drawn here is actually the whole of this is what we are referring to as a tree diagram. So this is basically what we are referring to as a tree diagram. Now, I want us to know that tree diagrams are normally very important, especially where we are dealing with more than 2 events or more than 2 attempts. For instance, we would have a problem enumerating this in a table this way if we were talking of a third toss. But when we are talking of a third toss in a tree diagram, actually we can simply add it. So I want us to get an example. Which we can work on and see how it is. I want us to get an example. So the example we are going to work with, we are going to get it from your KLB course book. I want us to get an example from KLB course book. Yes, here is the example. So I want us to get an example. So a coin is tossed 3 times. A coin is tossed 3 times. Draw a diagram to show all the possible outcomes. B, find the probability of getting 1 head, 2 heads and a tail in any order, 2 heads and a tail in any order, 3 2 heads and a tail in that order, 2 heads and a tail in that order. We can clean here so that we can continue. Four, 3 heads. 4, 3 heads. 5, at least 1 head. 6, no head. So I want us to work on those for now, and we see how it's going to work. So solution. So we are told that the first thing that we're supposed to work on is to draw a tree diagram. So we have to draw that diagram, and it's simple. We'll start by that. So we are told the toss is 3 times. So our first toss will give us only 2 options, either a head or a tail. Second toss. So second toss, if we had a head, we can still get a head and a tail. But in our second toss, it's also possible that the first toss was a tail. So we can still get a head or a tail in the second toss. The third toss, therefore, so this is third toss, we can still get a head and a tail. A head and a tail. A head and a tail. A head and a tail, like that. Now, I want to explain this because it is very important. When you're dealing with this, I want you to know that this is the first toss. In the first toss, our sample space only has two things. Either we are getting a head or a tail. In our second toss, we are now working from two bases. In the second toss, we are agreeing that in the first instance, probably we had a head. But if we had a head, we can still have a head or a tail. And it doesn't depend on what we had in the first instance. In other words, if we had a head in the first instance and we have a head now, we can go ahead and say that we now have two heads. Still, we can have a tail in the second throw, but at the same time we had a head in the first throw. So I want us to know that as we move on, we keep on branching. We keep on branching such that every other thing that comes from this first head, let me just show, though we will still erase this so that you are able to see. You have to see that all these things that are under this dotted line actually happen, and they are not dependent on the first head happening, but they are the descendants of the first head, such that from this we can only have head, tail, head if we actually had a head in the first instance. We can still have a head, head, tail only if our first throw was a head. So I want us to make it very clear, therefore, that as we move, our options keep on increasing, such that I want to illustrate simply from a simple family tree. A simple family tree. This is just illustration. If in your family there is a grandfather, or let's say a father. So father can give birth to two children, a boy and a girl. Still, a boy can give birth to two children, a boy and a girl. And the girl can also give birth to two children, a boy and a girl. Now, the boy of the boy here can still give birth to two children, a boy and a girl, and this girl can still have a boy and a girl, and this one can still have a boy and a girl, and this one also a boy and a girl. Now, when you look at all this, if we were, for example, to pick this girl here, although this girl has so many cousins, but how many generations are we talking of? 1, 2, 3. This is a grandchild to the father. Just like if we were to pick this boy here. In other words, whether this boy is a boy or a girl does not depend on anything. It can be a boy or a girl. But at the same time, is only existing. We can only talk of a boy in this family tree if the first grandfather here was a boy. So you are able to see, in this case, we can be able to talk of the first, like that. We can be able to talk of the second generation, like that. We can also be able to talk of the third generation, like that. So we are talking of progressive. So if these were coins, this would be our first toss, our second toss, our third toss. So in this instance, you can see we have our first toss, our second toss, and our third toss. So we were using that to illustrate, but I want you to see, we are talking of something like this. The more we continue moving, the more our sample space and the chances increase. The more our probabilities increase. So I want us to continue in that spirit. Let me clean this. Let me clean that way so we can continue. So having worked with this, we can now write here our outcomes. So our outcomes. So this is the sample space actually we are talking about, outcomes. So the first outcome can be, you will have ahead, ahead, and ahead in that order. So head, head, head. So I want you to notice that if you throw the coin 3 times and you have ahead and ahead and ahead, it means that you cannot have any other combination. All your responses are heads. Or another outcome, possibility can be the first throw being ahead, the second toss being ahead. I want us to see how we are moving ahead, ahead, and a tail. The third one being a tail. Or we can have a head, a tail, ahead. That will be head, tail, head. Or we can have head, tail, tail. So that is head, tail, tail. Or we can have tail, head, head. So that will be tail, head, head. Or we can have tail, head, tail. Tail, head, tail. Or we can have tail, 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 head. Tail, tail, head. Or lastly, we can have tail, tail, tail. Tail, tail, tail. So these are the possible outcomes that we can be talking of. These are the possible outcomes that we can be talking of. So I want you to realize immediately that the first question that was required of you was to draw a tree diagram to show all the possible outcomes. Now, normally it is important to write the probabilities in each case. Now, I want us to know that these are independent activities, such that in the first instance, for you to get a head or a tail, the chance is half-half. So the probability there is a half, and the probability is a half. In your second throw, if you are throwing a coin, there's no relationship with the first throw. So probability remains to be a half, 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 and a half. So all the chances are a half, meaning in every instance there is equal chance of getting a head and equal chance of getting a tail. That's why we are saying that half. So I want us to move ahead and start finding the second part, number B. So this is our sample space. Our sample space is HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. So that is our sample space, or what we also call probability space. That is our sample space, or what we also call a probability space. So I want us to go ahead and try to answer the questions that follow. So one head. What is the probability of getting one head? Now, probability of getting one head, we now have to look at our sample space here and see outcomes that only have one head. For instance, in the first outcome here, we have 3 heads. Here, 2 heads. 2 heads, 1 head. So we need this. We can tick it. We need it because it has 1 head. We have 2 heads. We have 1 head. So we need this as well. We also have 1 head here. These are now 3 tails, so no head. So these are the 3 possible outcomes we are interested in. Those are the 3 possible outcomes we are interested in. So what we always say, In this instance, therefore, we can say that the probability of getting only one head, probability of only one head can be given by the probability of head, tail, tail. So that will be head, tail, tail. Or it can be tail, head, tail. Probability of tail, head, tail. Or it can also be given by the probability of tail, tail, head. Probability of tail, tail, head. So those are the three probabilities. Now, this is something I want us to remember. For example, if we say head, tail, tail, what it means, we are looking at the probability of head and tail and tail. In other words, is the probability of head times the probability of tail times the probability of tail, in that order. So probability of head, tail, tail, this one, this is the probability. So this is a half and a half and a half. So that will therefore be given by a half for the head, followed by a half. I'm using times because this is and, followed by a half. Now, you have to know, along a branch, normally multiply. Even if you are having problem remembering that, just know along a branch we are multiplying. Now, or means plus. Or means plus. Probability of tail, head, tail is this one. So tail is a half times head, a half, times tail, a half. Or the third one, the probability of tail, tail, head, this one. So the probability of getting a tail here is a half. And the probability of getting another tail, a half. And the probability of getting a head in this case is a half. So you can work with that way. So you can go ahead and say that a half times a half times a half, this will be 1 times 1 times 1, which is 1 over 2 times 2 times 2, which is 8, plus, now these are similar brackets, so this will be 1 over 8 plus also 1 over 8. We agreed that whenever you are adding and the denominators are similar, simply add the numerator and pick one of the denominator. So in this case we have 8, then 1 plus 1 is 3 out of 8. So 3 out of 8 become the probability of getting only one head. The probability of getting only one head. So the second part, 2 heads and a tail in any order. 2 heads and a tail in any order. So in this instance, you will now say that 2 heads and a tail in any order. So we are looking in a situation where there are 2 heads. So this is one of them. Another 2 heads, we have 2 heads here, yes. Do we have 2 heads here? No. Do we have 2 heads here? Yes. We have a tail and 2 heads. Do we have 2 heads here? No. Do we have 2 heads here? No. And do we have 2 heads here? No. So it's only these 3 instances. Now, so this can therefore be given by probability of head, head, tail, head, head, tail, or the probability of can also be given by the probability of tail, head, head. Let's see. The first one was head, head, tail. Yes. Head, tail, head. Head, tail, head. Or we can also talk of probability of tail, head, head. Tail, head, head. So those are the 3 probabilities we can be talking of. So again, we can work on them. Head, head, tail, a half, a half, a half. So that will be a half times a half times a half. Or the probability of head, tail, head, head, tail, head, tail, head. To get head, there will be a half, tail, a half again, another head a half, or the probability of tail, head, head, tail, head, head, they are all a half. So that will be a half times another half times another a half. So in that instance, we will solve this first bracket, which will give us 1 out of 8, or is the same as plus 1 out of 8, or is again the same as plus 1 out of 8, giving us a total of 3 out of 8. So that is how we can solve the second part. That is how we can solve the second part. That is 2 heads and a tail in any order. 2 heads and a tail in any order. Now, viewers, because this is our question and our space is running out here, how I wish we could still erase here, because we are still using both of these parts, the equation and the tree diagram, to answer what we are dealing with. So you will allow me to clean here again so that we continue working. Now, meanwhile, it is important that I note that only 1 head was 3 out of 8, and 2 heads and a tail in any order was also 3 out of 8. So those are the answers we've gotten so far. So 2 heads and a tail in that order. So in this instance, we are now restricted. There is some order. In other words, we want 2 heads and a tail, and they must follow each other. So we must have a head, and a tail, and no any other order. So we have to look here and see where we have 2 heads first and then a tail later. Yes, so this will become the head, and then followed by a tail. So that will be the third one. So we will be looking at the probability of head, tail, like that. So looking at that head, the first head, the probability is a half, and we have to get a head again. The probability is a half, and we have to get a tail, which is also a half. So working on this, we can get 1 times 1 times 1, which is 1, over 2 times 2 times 2, which is 8. So therefore, the probability of head, tail is actually 1 out of 8. So we can go ahead and look at 3 heads, probability of 3 heads, probability of 3 heads. This was number 4. This is now number we are now in number 4. That was number 3. That was number 3. So we have number 4. So number 4 is now 3 heads. 3 heads. In other words, you are looking at probability of head, like that. 3 heads. And when we look at here, there's only one instance where we have 3 heads, which is this. So we'll say the probability of getting a head is a half, probability of getting another head is a half, and probability of getting a third head is a half. So when we multiply this across, we end up with 1 out of 8. 1 out of 8. Finally, we can go ahead and look at least 1 head. So this will be number 5, at least 1 head. Now, I want us to think. When we say at least 1 head, we are therefore looking at 1, 2, or 3 heads. Now, when we look at this situation, we have them. Head. So we have at least 1 head here. The second situation, head, tail. So we have at least 1 head. The third situation, head, tail. So we have at least 1 head. The fourth one, head, tail. We have at least 1 head. The fifth one, tail, head. So we have at least 1 head. Here there's a head, here there's a head. So there's only one place where we don't have a head, and it is tail. Now, we agreed that these are now mutually exclusive events. In other words, if you have head, you cannot at the same time have head, tail. Mutually exclusive outcomes when you look at the general outcomes here. Now, looking at this, therefore, we know that if we add all these probabilities, our answer is 1. Therefore, we can reason, because if we want at least one head, what we will do is we'll get the probability of head, 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 or the probability of head, head, tail, or so we will be adding all these probabilities up to here and fail to add the last one. Now, in that case, therefore, we can therefore decide that if we know that if we were to add everything, our answer is 1, therefore, we can say that at least one head, we can simply say this is 1 minus the probability of tail, 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 which will now be simpler. We'll only take this one, remove from 1, which will give us the total of everything remaining up. So this will be 1 minus tail is a half times another half times another half. So this will be 1 minus, when we work out a half times a half times a half is actually 1 out of 8, giving us what we call 7 out of 8. So that is how we can work on at least one head. That is how we can work on at least one head. But I want to challenge you. Challenge. Can you use the alternative? Use alternative way of adding all the other outcomes except tail, tail, tail. So I'm giving you that challenge. Can you try adding these ones and see if you'll end up with the same probability? And don't add tail, 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 so that we see if we end up with the same probability. Lastly, no head. The probability of no head. Now, when you look at that, the probability of no head means we have in all the 3 instances, we have tails. So it therefore means we are looking at the probability of tail, tail, tail. So the probability of no head is therefore the same as the probability of tail, 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 which can be given by a half times a half times a half, giving us 1 over 8. So that is how we can work on that when we are looking at the probabilities. Now, you see, when you're dealing with tree diagrams, viewers, it is important that you do a lot of practice. Now, these questions can be long, and therefore, normally it's important that when we leave an assignment behind, you make sure that you attempt and then you look at the comment section just below this video and put your comment there by asking questions so that we can respond in good time and so that it can help you. Otherwise, I want to tell you that questions like this normally attract a lot of points in exam, 10 points to be precise, questions like this, and therefore it's very important to be keen with them. Otherwise, I want to leave an assignment behind that you will attempt. So the assignment is this. Exercise, this is KLB, so this is the assignment. KLB exercise 13.4. I want to leave number 1, number 2, number 3, number 4, number 5, and number 6. So this is the last part actually of this topic, but we will continue to do further examples in the next class. My name is Geoffrey Mondi. See you in the next class.
Welcome to Manifested Publishers.
Hello, boys and girls. Welcome to Manifested e-learning platform. I am Teacher Purity and I will be teaching you Christian religious education activities for grade 4. So welcome to this lesson. Now allow me to welcome you to grade 4. It is a new class. Most of you are excited to be in this new class because you know you are going to explore a lot. Now let's talk about Christian religious education as a subject in this class. Christian religious education is a subject which helps us to understand different things that are related to Christianity. For example, knowing about God, how you are supposed to live with others, how some of the things you are supposed to do, they guide us on what we are supposed to do. In grade 4, we are going to learn about creation. We shall talk about self-awareness. We shall also learn Bible stories and many, many more. So it is my hope that all of you are going to enjoy learning CRE, especially for this class. Now, the very first topic that we are going to start with is about creation. And under creation, we shall start learning about self-awareness. Under self-awareness, we shall talk about my name makes me special. Let's remind ourselves the meaning of the word creation. Creation is bringing something that was not in existence to exist. You are creating something that was not there before. That is what you mean by the word creation. And for this case, you are talking about God's creation, whatever God created. Then we have the word self-awareness. Self means yourself. We are talking about yourself. And awareness is to understand or know something. So the word self-awareness means knowing more about yourself. You want to know more about yourself, who you are, what you like doing, who created you, and many, many more things about yourself. Now, self-awareness is knowing oneself much better. Self-awareness is knowing yourself better. Is knowing yourself better. And we are talking about my name makes me special. Now, all of us or each of us has a name. Why are you given a name? There is no single person who doesn't have a name. There's no person called nameless. No, at least each of us has a name. And a name is something that helps people to easily identify you, who you are. It is just an identification of you, of who you are. So we all have a name. Remember that I said a name helps us to be identified by other people. And when a person wants to talk to you or wants to call you, he or she will call you by your name. For example, I am Purity and another person is Mary. So Mary has a name. I also have my name. When a person wants to talk to me, he or she will call me by my name. So that means that people call me, let's say people call me, you are talking about yourself, people call me by my name. People call me by my name. And all children must have names. Remember that it is also one of the rights of children. A child has a right to be given a name. That's why everyone, after you are born, you are given a name. So people call me by my name. Why do people call you by your name? Even God knows you by name. So God created us in his own image, and therefore he knows us by our names. So God also knows me by name. So God knows my name. God knows my name. And because God knows your name or my name, he calls you by your name. When God wants to talk to you, he will just call you, Mary, I want to send you to maybe a place. God wants you to send you for a mission, maybe to preach, to sing, to dance, or even teach other children. So God knows my name. He therefore calls me by my name. he calls me by my name. God knows my name. He calls me by my name. If you can remember the story of Samuel, God just called Samuel by his name. He called him Samuel, Samuel. He called Samuel 4 times, but Samuel responded the 4th time. That means that God knows each and every one of us name. So God knows my name. He calls me by my name. Therefore, your name makes you special. So my name makes me special to God. My name makes me special to God. So my name makes me special to God. You are special in your own way before God. And God easily identifies you by your name. So that is all about my name makes me special. We've talked about self-awareness, which is knowing yourself better. And we all have a name. Remember, a name helps one to be identified easily by other people. And people call me by my name. That is why all of us have a name. And it is also a right. You are supposed to have, it is your right for you to be given a name. That is why when you are born, you are given a name. Then God knows my name. He calls me by my name. God knows you by your name. And therefore, when he wants to call you, he'll just call you by your name. You remember the story of Samuel? I've told you about it. God just called him by his name. Then lastly, my name makes me special to God. Your name makes you special before God. God knows that this is Shayla, this is Joy, this is Joanne, this is John, and he is able to know how special you are before him. Now I want to give you some work about what I have taught on self-awareness and my name makes me special. So take your exercise book and copy the questions. Now the exercise is here. Only 3 questions. The instruction says answer the following questions. Answer the following questions. Number 1, what is your name? So you are going to write your name in the blank space provided. Question 2, how is your name different from your friend's name? How is your name different from your friend's name? How is your name different from your friend's name? So you write there what you think. Then question 3, why should people call you by your name? Why should the people call you by your name and not another person's name? You also write your answer in the blank space provided. So thanks for being good listeners. Hope to see you in the next lesson.
Welcome to Manifested Publishers.
How are you doing, learner? Welcome to Manifested e-learning platform. I am Teacher Purity. Now we are still continuing our CRE activities and we still talking about self-awareness. And today we shall learn about rejoicing in the Lord. Rejoicing in the Lord. So welcome to the lesson and make sure that you are ready to learn. Now, rejoicing in the Lord. What does the word rejoice mean? To rejoice means to celebrate, or you are excited or happy about something. So rejoicing is simply being happy or excited. So rejoicing is being happy is being happy or excited. Rejoicing is being happy or excited, and you can be excited about an event or something that has happened. Now, we live happily with others when we rejoice. We live well with others when we rejoice. So, we live peacefully. We live peacefully with others. With others when we are happy or when we are rejoicing. We live peacefully with others when we are happy. When you show a jovial face, when you are happy, other people will also be happy to live with you because you are making them laugh, you are making them smile and enjoy life. So we live peacefully with others when we are happy. And that is what God wants us to do. God wants us to live happily and rejoice in Him. So God wants us to live happily. To live happily. God wants us to live happily and rejoice in Him. So God wants us to live happily and rejoice in Him. And this is found in the book of Philippians chapter 4 verse 4. In reference to Philippians chapter 4 verse 4. Let's see what the Bible has got to say about rejoicing in the Lord. Now the book of Philippians is found in the New Testament. Philippians chapter 4 verse 4, the Bible says, "May you always be joyful in your union with the Lord. I say it again, rejoice." I will read the verse again. Philippians chapter 4 verse 4, "May you always be joyful in your union with the Lord. I say it again, rejoice." So the Bible is also telling us to rejoice in our union with the Lord, who is our God and our Creator. That is why God wants us to live happily and rejoice in Him. There is this song that tells us about rejoicing in the Lord, and I will sing it for you. I know most of you know the song. Now the song goes like this. Rejoice in the Lord always, and again I say rejoice. Rejoice in the Lord always, and again I say rejoice. Rejoice, rejoice, and again I say rejoice. Rejoice in the Lord always, and again I say rejoice. Rejoice in the Lord always, and again I say rejoice. Rejoice, rejoice, and again I say rejoice. Rejoice, rejoice, and again I say rejoice. Rejoice in the Lord always, and again I say rejoice. Now in the song, the name rejoice has been repeated severally. It is insisting on us being happy, and not just a matter of being happy. We are also supposed to be happy in the Lord, who is our God. That is why we all times make sure that you are interacting with people in a manner that pleases God, a manner that makes God happy. That's what makes our God happy. Remember that being happy also makes us to have good thoughts and feelings. So being happy makes one to have good thoughts and feelings. So being happy makes one to have good thoughts and feelings. When you are happy, you are having good thoughts of sharing, of helping the needy, of visiting the sick, of even praising God, and they make one to live happily with others. I'm going to give you a memory verse which you'll practice to memorize and recite. Copy the memory verse in your exercise book. In the next lesson, we shall talk about something else on our choices, on our personal choices. Now the activity that you're going to do is just a memory verse where you're going to memorize and recite it. And it is from the book of Philippians chapter 4 verse 4. And it says, "May you always be joyful in your union with the Lord. I say it again, rejoice." May you always be joyful in your union with the Lord. I say it again, rejoice. So to memorize means that you know it offhand. You are able to say it without confirming from any place, either the Bible or your notes. You are memorizing it offhand. So practice memorizing the verse. I will see you in the next lesson.
Hello learner, my name is Dickens. So today we want to proceed by looking at salts, and today we want to look at solubility of salts, having defined a salt. So we said a salt is a compound formed when hydrogen ions from an acid are wholly or partially replaced by a metal ion. So today we want to look at how do salts behave when they are dissolved in water. So we want to do that by looking at a simple experiment here. So we have experiment. So I'll give you the procedure. So the first thing you do, you label procedure number 1. Label 4 test tubes. You label them as follows. Label them 1, 2, 3, and then 4. Then secondly, you put a small quantity of sodium sulfate in tube 1. Then the next one, sodium carbonate in tube 2. Sodium nitrate in tube 3, and sodium chloride in tube 4. So having labeled the 4 test tubes, so you take the first test tube, you put sodium sulfate. The second test tube, you put sodium carbonate. The third test tube, you put sodium nitrate. And the fourth test tube, you put sodium chloride. Then number 3, you add about 20 cubic centimeters of water to each test tube. And shake. So we are simply shaking well to make sure that the salt dissolves. If it does not dissolve, you warm. Of course, you're warming using some source of heat. Then number 4, you repeat the procedure using potassium sulfate instead of sodium sulfate, potassium carbonate instead of sodium carbonate, potassium nitrate instead of sodium nitrate, and lastly potassium chloride instead of sodium chloride. So you just repeating the procedure. You put in a test tube and then you add water, then you shake. Number 5, repeat the process using samples of different salts, and then after which you record your results in the table below. So we are saying for those salts which will dissolve, you'll put a tick. For the salts which will be insoluble, you'll put an X. So put a tick, this mark for soluble ones, and X for insoluble salts. So learner, this is how our table will look like. We are having a table of the results of solubility of salts. So our table will look okay. So we have our table there showing us the salts we are dealing with. We shall put them into the 4 categories. We shall have the sulfates, carbonates, chlorides, and nitrates. So our first salt here can either be potassium sulfate or potassium carbonate, potassium chloride, potassium nitrate. So these are the ones we are dissolving in water. Then we shall have the salts of sodium. We shall have sodium sulfate, sodium carbonate, sodium chloride, sodium nitrate, etc, etc. So these are the salts that we are dissolving in water. So when you dissolve these salts in water, we have said from the experiment, the ones which will dissolve, you'll put a tick. The ones which will be insoluble, you'll put an X. From the procedure, remember we have mentioned somewhere that if the salt is insoluble, then we warm. So we are going to realize that we have some salts which dissolve on warming. So these are the expected observations. If you dissolve potassium sulfate in water, the salt is going to be soluble. So for that case, you put a tick. The next one is potassium carbonate. So if you dissolve potassium carbonate in water, potassium carbonate is also going to dissolve. So we put a tick. The next one is potassium chloride. So if you dissolve potassium chloride in water, you'll realize that potassium chloride is a soluble salt. So we put a tick. The same applies to potassium nitrate. So potassium nitrate is also soluble. So we are through with the first class of potassium salts. The next one, we are going to look at the salts of sodium. So we are going to have sodium sulfate, followed by sodium carbonate. Then you have sodium chloride. Then we are going to have sodium nitrate. So observations, we are saying if you dissolve sodium sulfate in water, the salt is soluble. Also the same applies to sodium carbonate. Sodium carbonate is also soluble. It also applies to sodium chloride, it's soluble. And then lastly, sodium nitrate. So you can see the salts of both sodium and potassium are soluble in water. So the next one is calcium salts. We have calcium sulfate, calcium carbonate, calcium chloride, calcium nitrate. So how do they behave when they are dissolved in water? So we start by calcium sulfate. For the case of calcium sulfate, we'll realize that calcium sulfate, when you put in water, part of it will dissolve and then some of it will remain. And for that reason, we are saying that calcium sulfate is a salt that is slightly soluble. So here, for calcium sulfate, we say this one is slightly soluble. So if you dissolve in water, not all of it will dissolve. Some of the salt will remain. And for that case, we say calcium sulfate is slightly soluble. When it comes to calcium carbonate, if you put calcium carbonate in water, you'll realize that calcium carbonate is insoluble. And for that case, we put an X. So X means it is insoluble in water. Next, we have calcium chloride. If you dissolve calcium chloride in water, you'll realize that calcium chloride is a soluble salt. So you put a tick. Then the last salt of calcium is calcium nitrate. Calcium nitrate dissolved in water, it's a soluble salt, and therefore our correct observation is there is a tick. Next, we have the salts of magnesium. We have magnesium sulfate, magnesium carbonate, magnesium chloride, magnesium nitrate. So these are the expected observations. If you dissolve magnesium sulfate in water, it's going to dissolve. Therefore, we put a tick. Magnesium carbonate dissolved in water, it will not dissolve. And for that case, we are saying magnesium carbonate is insoluble. So we put an X. Magnesium chloride, it's a soluble salt. So we put a tick. Magnesium nitrate is also a soluble salt. Therefore, we put a tick. So those are the salts of magnesium. Next, we come to the salts of aluminium. We have aluminium sulfate. If you dissolve aluminium sulfate in water, it's going to dissolve. And for that case, our observation is we are going to put a tick, meaning aluminium sulfate is a soluble salt. Next, we have aluminium carbonate. So Lana, I want us to understand that aluminium carbonate, a salt by the name aluminium carbonate does not exist because the salts of aluminium normally hydrolyze in water to produce an acidic solution. And for that case, for this observation, we are going to put a dash, meaning aluminium carbonate does not exist. Because of that reason, that aluminium salts hydrolyze in water to produce an acidic solution. So therefore, we are putting here a dash because aluminium carbonate as a salt does not exist. So next we move to aluminium chloride. So if you dissolve aluminium chloride in water, it's going to dissolve. Therefore, we put a tick. We have aluminium nitrate, our last aluminium salt. So aluminium nitrate, if you dissolve in water, it's going to dissolve. So you put a tick. Next, we have the salts of zinc. We have zinc sulfate, zinc carbonate, zinc chloride, and zinc nitrate. Observations. Zinc sulfate is a soluble salt, so we put a tick. If you dissolve in water, zinc sulfate will dissolve. Zinc carbonate, if you dissolve zinc carbonate in water, the salt will not dissolve, and for that reason, we are going to put an X, meaning zinc carbonate is insoluble in water. Then we have zinc chloride. Zinc chloride is going to dissolve, therefore we put a tick. Lastly, we have zinc nitrate. Zinc nitrate dissolved in water, it's going to dissolve in water. Next, we have the salts of iron. We have iron sulfate, iron carbonate, iron chloride, and iron nitrate. So these are the expected observation Iron sulfate dissolved in water is going to dissolve, therefore we put a tick. Iron carbonate dissolved in water, the salt is insoluble, therefore we put an X. We have iron chloride. Iron chloride is also going to dissolve in water, therefore we put a tick. Then we have iron nitrate. Iron nitrate dissolved in water, it's a soluble salt, so you put a tick. Next, we have the salts of lead. We have lead sulfate, we have lead carbonate, lead chloride, and lead nitrate. All these are examples of salts. We have only put them into categories depending on the anion that is there. So we have 4 anions. We have sulfates, we have carbonates, we have chloride, and we have nitrates. Now, lead sulfate dissolved in water, the salt is insoluble, therefore we put an X. And then we have lead nitrate. Lead nitrate dissolved in water, the salt is going to dissolve, therefore we put a tick. Next, we have the salts of copper. We have copper sulfate, we have copper chloride, copper carbonate, copper chloride, then copper nitrate. Expected observations: copper sulfate, if you dissolve copper sulfate in water, it's going to dissolve, therefore you put a tick. Then the next one, we have copper carbonate. Copper carbonate in water, it's going to be insoluble, therefore you put an X. Next, we have copper chloride. Copper chloride dissolved in water, the expected observation is going to be insoluble, therefore we put an X. And then lastly, we have copper nitrate. So copper nitrate dissolved in water, it's going to be soluble in water, therefore we put a tick. Lastly, we have the salts of barium. Barium, we start by barium sulfate. Barium sulfate, when it's dissolved in water, it's going to be insoluble, and for that case, our table, we're going to put an X, meaning barium sulfate is insoluble in water. Next, we have barium carbonate. If you dissolve barium carbonate in water, it's going to be insoluble, therefore you put an X. Next, we have barium chloride. Barium chloride, this one is soluble in water, therefore we put a tick. And then lastly, we have barium nitrate. So barium nitrate, dissolved in water, the salt is going to be soluble. So learner, we are saying these are the expected observations from the experiment we have mentioned earlier. So having said that, I now want us to look at a summary. From the table, you can see that both potassium and sodium, you can see their salts. Potassium sulfate, potassium carbonate, potassium chloride, potassium nitrate, all these are soluble. The same applies to sodium sulfate, sodium carbonate, sodium nitrate, and sodium chloride. So in summary, we are saying that all salts of both sodium and potassium are soluble in water. That's the first observation we can make from this table. The second observation, learner, we are saying, if you look at this column of nitrates, you should be able to notice something about nitrates. Remember, we have said where there is a tick, it means the salt is soluble in water. So our second observation is what? That all nitrates, any salt that contains a nitrate, we expect it to be soluble in water. That is observation number 2 from the table. Then the third point, we can get it from the column of carbonates. Apart from potassium carbonate and sodium carbonate, you realize that the other carbonates are insoluble. So we are saying our point number 3 is this, that all carbonates are insoluble except the carbonates of sodium and potassium. These two are insoluble. Our fourth point, conclusion, is obtained from the column of sulfates. You can see, apart from lead sulfate and barium sulfate, the other sulfates are soluble in water. So we are saying that all sulfates are soluble in water with the exception of lead sulfate and barium sulfate. And lastly, our conclusion point is on chlorides. You can see apart from lead chloride, we are saying the other chlorides are soluble in water. Of course, we have said lead chloride is soluble in hot water. So, learner, we want to come with a conclusion basing on those observations that we have seen there. So, conclusion, our first point. Conclusion, our first point is as follows. That all salts of sodium, potassium are soluble in water. All salts of sodium, potassium, so we can add ammonium because ammonium is another example of a positively charged ion, and ammonium are soluble in water. Think of any salt that has the word sodium, that has the word potassium, that has the word ammonium. Sodium sulfate, potassium carbonate, ammonium nitrate. So long as it has these three cations, then that salt will be soluble in water. That's number one. Number two, all nitrates are soluble in water. We can see that from the table earlier on. Any nitrate you can mention, sodium nitrate, potassium nitrate, magnesium nitrate, any nitrate you think of, then if you dissolve it in water, that nitrate will be soluble in water. Our third point about conclusion is coming from carbonates. We have said earlier that all carbonates are insoluble. That's the point we are repeating, that all carbonates are insoluble. But there is an exception. Remember earlier on we have said, the first point we have said is that any salt of sodium, potassium or ammonium is soluble. But here we are saying all carbonates are insoluble. That means we have some carbonates which are soluble. And these are the carbonates of sodium, potassium, ammonium. So we are saying all carbonates are insoluble except carbonates of sodium, potassium and ammonium. So we have said earlier on that from the conclusion point number one, potassium, sodium and ammonium salts are soluble. But here we are saying all carbonates are insoluble. That means the carbonates of these three, sodium, potassium and ammonium, if you put them in water, they'll dissolve in water. So we are saying if you put sodium carbonate in water, it will dissolve. Put ammonium carbonate in water, it will dissolve, as well as potassium carbonate. Our fourth point of conclusion is coming from sulfates. We are saying that from the table we said earlier on that all sulfates are soluble. So that's the point we are emphasizing, that all sulfates are soluble. But we mentioned the ones which are insoluble. We said barium as well as lead sulfate. So these two are insoluble. So otherwise the rest are insoluble. So we are saying all the sulfates are soluble except barium sulfate and lead sulfate. But remember, we said calcium sulfate is slightly soluble in water. So it's good you also mention that one, that calcium sulfate is slightly soluble. Calcium sulfate is slightly soluble. Then our last point of conclusion is coming from chlorides. So we said from the table, chlorides are, most of them are soluble. So that's the conclusion we are coming up with, that all chlorides are soluble. All chlorides are soluble. And remember, we have said, we gave an example of the one that is soluble in hot water, and that was lead chloride. So it's good we mention that lead chloride is soluble in hot water. So you can only make lead chloride to dissolve when you warm the mixture. So Lana, we are saying that from these 5 points, the salts of sodium, potassium, and ammonium are soluble. Our second point is that all nitrates are soluble. Our third point is carbonates. All carbonates are insoluble. All carbonates are insoluble. All nitrates are soluble. And then all sulfates are soluble. All chlorides are soluble. We have given exceptions. So we have come to the end of our lesson. It's good for your revision. You try and answer these questions. So I want you to try these questions. So the first question is, identify the cations. Identify the cations that form. Identify the cations that form soluble salts. That's our first question. Our second question is, comment on the solubility. Comment on the solubility of sulfates. Give a brief comment on sulfates. Give a brief comment on chlorides. Give a brief comment on carbonates. And give a brief comment on nitrates. And that will be the end of our lesson for today. I want to thank you for being a good student, and I wish you the best.
Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. Remember, the program is still Manifested Online Classes. We are still continuing with simple classification of substances topic, and our subtopic is separation of soluble, solid, liquid mixtures. If you remember, in our previous lesson, we discussed, or we learned how you can be able to separate a mixture of sodium chloride and sand. We said there are 2 methods you can use, or which are used together, which are filtration and evaporation. The first step was to put the mixture in a beaker. Once you put the mixture in the beaker, you're supposed to add water to the mixture and stir after adding water. When you stir, sodium chloride dissolves in water while sand does not. Therefore, the next step will be to conduct a filtration process. When you conduct filtration process, sand is the residue, while sodium chloride solution is the filtrate. Therefore, filtration method separates sand from a solution of sodium chloride. Then after obtaining this filtrate, which is now sodium chloride solution, you carry out evaporation. You evaporate water from sodium chloride solution, and you will be left with sodium chloride salt. So that is how you are able to separate a mixture of sand and sodium chloride. I hope you can be able to describe that. Therefore, in this lesson, we are going to discuss how you can be able to obtain a solvent from a solution. How can a solvent be obtained from a solution? That is what I want us to learn in this lesson. And by the end of this lesson, you should be able to explain how you can be able to obtain a solvent from a solution. Remember again, a solution contains a solute and a solvent. Therefore, we want to explain, or we want to learn how you can be able to obtain a solvent from that solution. Therefore, separate how can a solvent be obtained from a solution. It is a simple experiment just to illustrate how you can be able to obtain a solvent from a solution. I want to write a simple procedure which we are going to use, and I will explain it to you so that you understand what we are doing. Therefore, this is the procedure we are going to use, and that is the diagram to explain what we are doing here. Step number 1, place 20 centimeter cubed of sodium chloride solution in a boiling tube or a round bottom of the flask. But in our case, we have used a boiling tube. Heat the solution until all the solvent has evaporated. You're supposed to heat until all the solvent has evaporated. So this is a solution of sodium chloride inside. So that being a solution of sodium chloride, you are supposed to heat until all the solvent has evaporated, and the solvent in this case is water. So heat until all the solvent has evaporated. Then record your observations. The observation is going to be a white solid is left behind. A white solid will be left behind. The white solid left, this is salt. And the salt is sodium chloride. If we had used sodium chloride, because we had used sodium chloride, then whatever is left is a white solid. And this white solid is a salt, and the salt is the sodium chloride. All the water has evaporated. You're left with sodium chloride salt. The next step, place 20 centimeters cubed of sodium chloride solution on a watch glass. Then place the watch glass on a water bath. Then heat sodium chloride solution to dryness. If we had that, if this is the watch glass, this is the water bath. It is on top of a tripod stand. You are heating, and of course there is the wire goes to ensure there is uniform distribution of heat. If this is the solution, it's a solution of sodium chloride. That is heat. If you heat or evaporate this solution to dryness, again you are going to be left with a white solid. So the same thing is going to be left behind. A white solid will be left. Once all the water is evaporated, you're left with that white solid. Then you're supposed to record the observation, and the observation is a white solid which is left behind after all the water has evaporated from that solution. So that white solid is left, and the white solid is salt, which is sodium chloride. Then the other thing, place the liquid in tube B on another watch glass. Place the watch glass on the water bath, then heat the liquid to dryness. So you get a little amount of the liquid here. When you get that liquid, then again you repeat like you did at this point, and therefore the diagram will have a diagram like this. That is the beaker. Then we are talking about tube B. So place the liquid in tube B on another watch glass. This is the liquid, and the liquid in tube B is a colorless liquid. Therefore, the colorless liquid is on a watch glass. Then you put it on a water bath and heat to dryness. And you also observe what is going to happen after you heat it to dryness. Now, what happens when you heat this salt solution? When you heat this salt solution to dryness, water evaporates, leaving behind salt, which is sodium chloride. The water which evaporates now passes through this delivery tube as it condenses. Some of it condenses in the delivery tube, leading to formation of a colorless liquid. So the water vapor evaporates, some of it condenses on the delivery tube, and it comes at this point, and that's why you have this colorless liquid. The colorless liquid is water. This is water, and this water does not contain dissolved salts. The water does not contain dissolved salts. The purpose of this cold water is to cool the water vapor. Once the water vapor now drops at this point or drops through the delivery tube, it is now cooled by this cold water. So that is the purpose of the cold water at that point. Then remember, we are still looking at how can our point of concern is how you are able to separate a solvent from a solution. And using this method, it is possible. We had a solution, a salt solution, and this salt solution is sodium chloride solution. We have heated the sodium chloride solution. Then to dryness, you heat sodium chloride solution to dryness. Then water evaporates. You are left with salt or sodium chloride solid in the boiling tube. Then the water which evaporates now is collected as the colorless liquid at that point. Therefore, the colorless liquid collected here does not contain dissolved salts. And when it is heated at this point, when you heat this colorless liquid, you obtain at the lower point, then this colorless liquid, when you heat this to dryness, then there is nothing left on the watch glass. There is nothing left on the watch glass because this colorless liquid does not contain dissolved salts. That's what happens. This method of separation is called simple classification. Sorry, simple distillation. It is called a simple distillation method. Therefore, through a simple distillation method, we can be able to obtain a solvent from a solution. And it is possible using this method. We have heated a solution of sodium chloride to dryness. We are left with salt. Water evaporates and it is collected as a colorless liquid. But as it evaporates, some of it condenses on the cooler parts of the delivery tube, and at the end, then it is collected at that point. And again, we have seen that the function of the cold water is to condense the hot water vapor into a liquid, to condense the hot water vapor into a liquid. And that is how we are able to obtain a solvent, which is now water, from a solution. When we were heating this solution, then there was salt left. There was salt left. And this salt is because this solution was containing concentrated, or it was containing salt in it. When we heated these, there was nothing left on the watch glass because this colorless liquid, which is now water, does not contain dissolved salt. And therefore, that is how you are able to separate, or you are able to obtain a solvent from a solution. And this method is a big condenser. A Liebig condenser is used to improve the condensation of the water vapor to form the liquid. And when you use a Liebig condenser, then this is what to expect. Therefore, that is what is going to happen when you use a Liebig condenser. Remember, we have said that the function of the Liebig condenser is to condense the water vapor into a liquid efficiently. When this salt solution is heated, water evaporates and you are left with salt. That is when you evaporate it to dryness. Then this water vapor now passes through this point, then goes down through the Liebig condenser. This is what you are calling the Liebig condenser. Then the Liebig condenser has 2 points where the cold water is getting in, which is now on the lower side, and where the water is coming out on the upper side. This cold water, the function is to cool the hot water vapor. So this cold water is cooling the hot water vapor as it is passing through this point. When this cold water cools the hot water vapor, when it cools the hot water vapor passing through this delivery or this passing through this Liebig condenser, this water in the process of cooling the hot water vapor also gets hot. And that is now why we have the hot water coming out on the upper side. The hot water is coming out on the upper side. But the reason why we have the cold water on the lower side and not on the upper side is to ensure that it is more efficient, because when the cold water gets in on the upper side, then it just passes so fast and getting out on the lower side, and therefore it will not be efficient in cooling the hot water. Not hot water, but hot water vapor, which is passing through the Liebig condenser. And now whatever is collected is the distillate, because the method, we are calling it simple distillation. And this distillate is now a liquid. And again, remember, we are discussing how you can be able to obtain a solvent from a solution. And that is how you are able to obtain a solvent from a solution. Therefore, understand that very well. Maybe to connect or to repeat a little bit what I've said, that in this method, you are still able to separate the solvent from this solution, but this method is not very efficient in that separation compared to this. Therefore, the function of the Liebig condenser here is to make the separation of the solvent from the solution more efficient. It becomes more efficient when you use a Liebig condenser than when you don't use it. And I've explained it to you how the Liebig condenser is of great importance. It has 2 points where the cold water is getting in on the lower side. This cold water which is getting in is cooling the hot water vapor from this position. When this salt solution is heated, when you heat this salt solution, then the water vapor evaporates, then follows this path. The cold water which is getting in at this point is cooling that hot water vapor, because it must be hot, because it has been heated at this point. Then that cold water in the process of cooling, or in the process of condensing the water vapor into a liquid, then it also gets hot. And the hot water is now the one which is getting out on the upper side. And that is how you can be able to obtain a solvent from a solution. Therefore, put that always in mind, and again ensure that you can be able to explain that very well. ensure that you can be able to explain that very well. Therefore, the method is simple distillation. And that is a method you can use to obtain a solvent from a solution. Therefore, that brings us to the end of our lesson today. But before that, I will leave you with this question, which is the assignment today. And the assignment is, name the method which can be used. Name the method which can be used to obtain water, which is the solvent, from a solution of sodium chloride. Name the method you can use or which can be used to obtain water from a solution of sodium chloride. That is a simple one. In the next lesson, we'll be discussing the separation of liquid mixtures. See you in the next lesson.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Welcome to this lesson. That's mathematics lesson. I'm Purity and Zelimo. Our topic is still trigonometry. Trigonometry. And in this lesson, we are going to deal with the last bit in this topic, that is trigonometry 3. And our last bit in this is solving, we want to look at solving trigonometric equations. Solving trigonometric equations. That is our last bit in this topic, trigonometry 3. So in our last lesson, we were looking at the transformations. That is whereby we looked at the stretch. We also looked at the translation. And in this we said, when you have a general equation, y is equal to a sine, it can be sine or cos, bx plus c, where a, b, and c are constant. We say that a is the amplitude. A is the amplitude. Then 360 degrees divided by p is the period. Then we have our c, all over p, which is the phase. We have it as our phase angle, and then we have, this is the phase angle, sorry, not the phase angle, but the shift angle, not the phase angle. We have here the phase shift, which is negative. Then we have our C here, which is the phase angle. So that's what we have when we have this as our general equation. So in this lesson, we are going to look at now the solution of trigonometric equations. In the previous knowledge, that is in the previous lessons, especially on a topic like algebra, we realize that when we want to solve an algebraic equation, we get one answer. That is the answer is finite. We have finite roots. Finite roots. For example, when you are solving, I have x plus 2 is equal to, for example, maybe is equal to x. When we have such, this is an algebraic equation. When we are solving this, we simply have a half x, we take x to the other side, minus x is equal to negative 2. And therefore, in this, we are going to have negative half x is equal to negative 2. So we can multiply both signs by negative 2 by negative 2. So this will cancel. We have x is equal to 4. So you can see we have a finite root. Our x is equal to 4. Now, in solving trigonometric equations, we can obtain infinite number of roots. We obtain infinite number of roots. And therefore, to ensure that we have a certain answer, we give, or in a question, we are given the range. For example, when you are given the range 0 degrees, maybe for example up to 118 degrees, you only give the roots that are in between here. So when you get an answer like negative 30, you don't include it. When you get an answer, for example, 190 degrees, again, you don't include it. So in this case, for the trigonometric equations, we'll be given the range, and therefore our answers should be within the range. So I want us to do various examples so that you can be in a position to solve the trigonometric equations. And in this case, we are going to look at two methods. And one of the methods will be solving the trigonometric equations by simplifying. So one method will be by simplifying simply whatever we have, or evaluating. Then number 2 will also be solving graphically. That is using the graphical method. And I want us to start with the first one, whereby we'll be simplifying, then we can move on to the graphical method. So I'd like to give you a few examples in this. We have examples, can give you like 3 examples. So we are told, number 1, solve the following trigonometric equations. Solve the following trigonometric equations. So in the first one that I want us to start with, we have sine 2x is equal to cos x. And we have been given for the range is from 0 degrees to 360 degrees. So that's what we have, and we are supposed to solve. Here we are simplifying. We are not using the graphs. We can again solve this using the graph, which we are going to do in the next part of the lesson. So we have this, sine 2x is equal to cos x. Our range is from 0 to 360 degrees. And therefore, when you have such, remember here you have sine and you have cos, we know one thing with the sine and cos, that for the complementary angles, the sine of a certain angle is equal to the cos of that complementary angle. So in this case, we can simply come and say, therefore, sine 2x is the same as cos 90 degrees minus x. It is simply the same. Sorry, not sine, not cos, but again sine. We still have sine here. Sorry, that is sine 2x is equal to this, is the same as sine 90 minus x. That is from our previous knowledge. So we have it as this, and therefore we can simply come, this is a 90 degrees, we can come and get the sine inverse on both sides, on dividing by sine. So in this case, we are going to have, when we get the sine inverse of sine 2x is equal to the sine inverse of sine 90 degrees minus x. So when we have that, we are going therefore to get this as 2x is equal to 90 degrees minus x. So we have therefore 2x is equal to 90 degrees minus x. We want to find the value of So we can bring the like terms together. We'll have 2x plus x, 2x plus x is equal to 90 degrees. So we'll have 3x is equal to 90 degrees. Now I want us to be very keen here because we want to get the answers within this range. As you can see from this, our sign is positive. The sign is positive. The sign, our sign, this trigonometric ratio is positive. And we have seen that we have the first one, which is 90 degrees. Again, we just come and consider the unit circle. We consider the unit circle and consider where the sign is positive. So in the case here, we have the sign here is positive. Again here, the sign is positive. Here it is negative, and also in the fourth quadrant. So in this case here, we have the 90 degrees. That's what we have. So we also need to come and get on the other quadrant. What do we have? So we have 90 degrees. Then here we are going to have, therefore, we have, this is 180 degrees minus theta. Then here we have 180 degrees, then plus, we can now make first x. We have, this is 3x, and therefore we can divide this by 3 so that we get that acute angle, and therefore our x will be equal to 30 degrees. Now we have 30 degrees here. We have our sign being positive, so we have this and this. So we'll have 30 degrees. We also have another one whereby we have 30. Then here in the second quadrant we have 180 degrees minus 30 degrees. Then we have 150 degrees. Then if we go round once again to come back to this point here, we'll now be having 360 plus 30, which will be outside the limit because it is to 360 degrees. And therefore, our possible answers therefore will be our x is either equal to 30 degrees and also equal to 150 degrees. So that's the solution for x within this range, because when we go once again, we'll get more than 360 degrees. And that's why we say, because we have infinite number of roots, we need to consider the limit that is given. Then we can do another example. Let's do another example. That is part B. We are still solving that the trigonometric equations. We have 2 sine. Here we have x plus 30 degrees is equal to 0.766, and we have been given the range that is from 0 all the way to 360 degrees. So we need to solve that one again. So in that case, this is what we have. So we can first remove these 2 by dividing all through by 2. Dividing through by 2. So when we divide this, we get sine x plus 30 degrees. Then we divide 0.766, we divide it by 2, we get this as 0.383. Then after that, we get the sine inverse on both sides. So we get the sine inverse of the sine x plus 30 degrees, which is equal to now the sine inverse here of 0.383. So in this case now we are going to end up getting x plus 30 degrees is equal to the sine inverse, the shift sign of that answer, which is 22.5 degrees. So that's what we have. And as we can see again in this, our sign is positive. Even from this, the sign here, this is positive, it's not negative. We have it as positive. And therefore, in the unit circle again, we consider where sign is positive. So in that again, we'll come and have our acute angle is 22.5 degrees. So with the unit circle, we have the unit circle. Here the sign is positive. Again here the sign is positive. So we have the first angle, which is 22.5 degrees. So we'll have our x plus 30 degrees being equal to 122.5 degrees. Then we move on. On this side here we'll have 180 minus our theta, and our theta is 22.5. So we'll have 180 minus 22.5. So in this case we get 157.5 degrees. Then again, if we move one more round to come back on this side, we'll therefore have the other one as 360 plus 22.5, which will give us 382.5. So here we have 382.5, and we continue. So our x in this case, because now this one is already more than 360, so our x therefore will be, the first one will be, x will be 22.5 minus 30, which will be negative. It will be negative 22.5 minus 30, which will be negative 7.5 degrees. Then the other one will have x plus 30 being equal to 157.5, and therefore our x is 157.5 degrees minus 30. So when we subtract 30 here, we get 127.5 degrees. Then with the other one again, we have x therefore will be 382.5 minus 30 degrees. So we'll have 382.5 minus 30 degrees, we get 352.5 degrees. And therefore our solutions for x, we cannot have this because it is not within the limit. So we'll have therefore 127.5 degrees, and we also have 352.5 degrees. So if we continue, we'll be outside 360. So that's what we have for the solutions. We can do the last example. The last example on this, we can have the following. That is on solving trigonometric equations. So in this one we have the following. Part C, we have a half tan 2x minus 10 degrees, and we have it as 0.577. So that's what we have in this case, and therefore we require to get the values of x within this, the range we have been given, the range that is up to 360 degrees. 0 degrees up to 360 degrees. So in this again, we can multiply by a half so that we can remove this fraction. So multiplying by 2. We multiply by 2, not a half. Multiplying through by 2. When we multiply this by 2, we'll get tan 2x minus 10 degrees is equal to, we multiply 0.577, we multiply it by 2, and we get 1.154. 1.154. Then the next thing, we need to get the tan inverse on both sides. So we have the tan inverse of tan 2x minus 10 degrees is equal to tan inverse of 1.154. So on this, when we find this, we remain with 2x minus 10 degrees is equal to the shift tan of that, which is 49.1 degrees. Again, in this case, we just do it the same way we've done here. Our tangent here is positive. Our tan is positive, and therefore we need to come and now consider our unit circle. This is our unit circle where tangent is positive. Here we have sine positive, cos positive, and therefore tangent is positive. Here our tangent is negative. Here we have negative and negative, so this is positive again. Here we have negative tangent. And therefore, we consider where the tangent is positive. So our acute angle here is 49.1 degrees. So we'll have therefore 2x minus 10 degrees will be equal to 149.1 degrees. Then in this quadrant here, which is 180 degrees, have therefore 180 plus 49.1, and we get 229.1 degrees. Then we can still move on because our limit is up to 360 degrees. So we can come back here, whereby now after another round that is 360 degrees, now we'll have 360 plus 49.1, which is going to be 1904, 409.1 degrees. So if we continue, it will be more than the 360 degrees. And therefore in this, we can reach up to there and therefore say, let's see whether we need to continue. Let's move on to the next one and see. We've gotten this as 409.1. Then we are moving direct to this, and therefore we'll have 409.1, then plus 180 degrees, which is 500, because we have here 409.1. This is to here we have 180 degrees, so we'll have plus 180 to get 589.1. So we have 589.1 degrees. We can stop at that and see. So in this case, we'll have 2x minus 10 is equal to 49.1 degrees. So our 2x will be 49.1 degrees plus 10 degrees. We divide by 2. That is for the value of x, divided by 2. So our x therefore will be 49.1. We are adding 10, then we divide by 2. So this will be 29.55 degrees. Then we move on to the second one, whereby we have 2x. Our x in this case will simply be, x will be 229.1 plus 10. We divide by 2. So we'll have 239.1 divided by 2, which is 119.55 degrees. Then again we move on to the other one, our x, which will be 409.1 plus 10 degrees divided by 2. So we have 419.1, we divide by 2, and this will be 209.55 degrees. Then the other one, the last one in this case, we have 589.1 plus 10 degrees divided by 2. So we get 599.1 divided by 2, which will be 299.55 degrees. And therefore we can say, because if we continue again, we'll have a value which is greater than 360, and that is our limit. And therefore our values of x therefore will be, our first x is 29.55 degrees. We also have 119.55 degrees. We also have 209.5 degrees, and we have 299.55 degrees. So those will be those are the values of x within this limit that you've been given here after solving this. So when solving, remember when we have this 2x minus 10 You get the acute angle, you solve it, then you are going now to get the value of x using this. 2x is minus 10 is equal to this. You get the value of x. You get all the values of x within the range that is given. So I'd like you to do the following exercise. I'd like you to solve each of the following. Solve each of the following equations in the range. You'll always be given the range. In the range, this is degrees, that is 0 to 360 degrees. For the first part, we have a half sine x is equal to a half. B, we have 2 cos a half x is equal to 1.414. Then we have C, a third sine x plus 30 degrees is equal to 1/3. And finally, number D, we have 2 tan into bracket x minus 15 degrees is equal to 0.7164. So ensure that you solve that. That is one of the methods. This is one of the methods of solving trigonometric equations. And I would like to explain briefly on the second method of solving trigonometric equations. The second method briefly, because we have already plotted so many graphs and therefore this will be very easy. The other method of solving trigonometric equations, number 2, is graphical method. The graphical method, and in this case we'll do one example which will help you on the solving of trigonometric equations by the graphical method or graphically. So in this case, I'd like us to do this one question. This is the question that we've been given on solving that is using the graphical method. So we have, the question is, draw the graph of y is equal to 2 sin x for the value 0 degrees up to 360 degrees. Then on the same axis, draw the graph. On the same axis, draw the graph of y is equal to cos x. Hence, solve the equation. The equation is given here. 2 sin x is minus cos x is equal to 0. I'd like us to solve that one. Draw the graph of y is equal to 2 sin x for that range. On the same axis, draw that graph of y is equal to cos x. Hence, solve the equation. 2 sin x minus cos x is equal to 0. So in this case, we are going to plot them each at a time, and we plot them on the same axis. So we can start with the first one. Y is equal to 2 sin x. 2 sin x. So in this, we simply come. This is what we have. We have our x here, degrees. Then we can have our 2x. And finally, our y, which is equal to 2 sin x. That is, we'll be taking 2 sin. We have here 2 sin x. It is not 2x. it is simply sine x, 2 sine x. Sine y is equal to 2 sine x. That is the value of y, 2 sine x. So we are simply getting the sine of x, then we multiply it by 2 to get the value for our y. So if we start with the 0 degrees, we have the degrees here already, 0. Then we'll move on to 30. We can move on to 60, 90, 120, 150, 180, 210, 240, 270. We have 300, 330, and 360 degrees. So we'll get the sine x here. Then we can also come and get your y, which is equal to cos x. So in this case, we'll be getting cos of this, cos of this. So we fill that so that we can plot the graphs. So in this, we have 2 sine 0, which should be equal to 0. We have 2 sine 30, which is 1. We have 2 sine 60, which is 1.7. We have 2 sine 90, which is 2. We have 2 sine 120, which is 1.7. We have 2 sine 150, which is 1. We have 2 sine 180, which is 0. We have 2 sine 210, which is negative 1. We have 2 sine 240, which is negative 1.7. 2 sine 270, negative 2. 2 sine 300, negative 1.7. We have 2 sine 330, negative 1. And finally 2 sine 360, which is 0. So we put them to one decimal place. Then we have cos x. So we have cos 0, which is 1. We have cos 30, which is 0.9. We have cos 60, which is 0.5. Cos 90, 0. Cos 120, negative 0.5. Cos 150, negative 0.9. Then we have cos 180, which is negative 1. We have cos 210, which is negative 0.9. Cos 240, which is negative, that is cos 240, which is negative 0.5. We have cos 270, which is 0. We have cos 300, which is 0.5. We have cos 330, which is 0.9. And finally, we have cos 360, which is 1.0. Then now, we can now plot the graphs, draw the graph. Then we can solve the equation from the graph. We are plotting on the same axis. Therefore, this one we've plotted severally. So we have our y-axis. The highest value in our case here is 1. Our highest value here is 1. Then here we have from 0 to 360 degrees. So in this case, we can have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, and 13. So that's what we have. So here we have 0. This is 30 degrees, 60 degrees, 90, 120, 150, 180, 210, 240 degrees. Then we have 270, we have 300, 330, and finally 360 degrees. Then here we also have the highest being 1, 0.5, 1, 1. So we have here 0.5, we have 1, negative 0.5, and we have 1.0. This is 1.0. So that's what we have. We need to plot each graph at a time. So we can start with y is equal to 2 sin x. We have 0, 0. Then we have 30, 1. Our 30, we have 1. We have 60, 1.7. 1.7, somewhere here, sorry. We have up to 1.7. So the highest is 1.7, so we need to add this. This is 1.5, 2. So we have this as 1.5. Here we have 2.0. Again, on the other side, we need to add this. We have negative 1.5, negative 2.0. Our highest value is 1.7. That's the largest. So we have 60 degrees, we have 1.7, which is somewhere here. Then we have 90 degrees, we have 2. Actually, our largest is 2, not 1.7. We have 2 here. Then we have 120, 1.7, again here. Then we have 151, we have our 1 here. Then we have 108, we have 0. Then 210, we have negative 1. So in this case, we have a point that way. Then 240, we have negative 1.7, which is somewhere here, 1.7. Then 270, we have negative 207, we have 270, we have negative 2, which is here. Then 300, we have negative 1. We have 300, sorry, we have negative 1.7, which is here. Then 330, we have negative 1, which is here. Then finally 360, we have 0. Then we need now to plot that. We need to come and plot that. So we are going to have the following. This is our curve. This is the wave that we are going to obtain. This should be a smooth one. In case you see that it's not smooth, know that there is somewhere where there is a mistake. So after that, we name it. Our y is equal to 2 sin x. Then we move ahead and plot the other one. We have 0, 1. We have it there. Then we have 30. We have 0.9. 30. We have 0.9, almost 1. So it's somewhere here. Then we have 60. We have 0, 1. Then we have 30, 0.9. We have 60, 0.5. 60, we have 0.5. 90, we have 0. 120, we have negative 0.5, which is somewhere here. Then 150, negative 0.9. Negative 0.9 is somewhere here. Negative 0.9. Then 180, we have negative 1. We have, sorry, this is 0.9. For 150, we have 0.9. It should be here. Then for 180, we have negative 1, which is slightly higher here. Then 210, we have 0.9, which is negative here. Then 240, we have negative 0.5. Negative 0.5 is somewhere here. Then we have 270, we have 0. Then 300, we have 0.5, which is somewhere here. Then we have 330, 0.9. 0.9, it's somewhere here for 0.9. And finally, we have 360, which is 1, which is somewhere there. So that's what we have. Again, we join the points to get the other curve. So we are going to have it this way. So that's what we have. This is our turning point here. Move on to this point. Then again we move on to, the point is still there. We move on to 240. We have negative 0.5. Negative 0.5. And 210, we have negative 0.9. So this one is the issue. So we have it there. So we are going to have it this way, moving all the way to 270. 270, then this way, all the way to that other point. So that's what we have. And this curve is y is equal to cos x. So that's what we have for the two curves. That is for the two waves. We should ensure that the curve is smooth. And then that's what we have. Then after that we are told to solve. We are solving 2 sine x minus cos x is equal to 0. Now if you look at this, 2 sine x is this and the cos x is this. And therefore we can write this one as 2 sine x, therefore is the same as cos x, is equal to cos x. This simply means this 2 sine x is equal to cos x. And therefore, we are going to look at the point whereby the curve 2 sine x equals the curve cos x. And this will be at the point of intersection. It is at the point of intersection of the two curves where they intersect. We have one point here and we have another point here. So where they intersect is the solution for this. And therefore, our values of x will be, you just come and read the first angle here, this angle. Come and read this angle. It may not be very accurate for my case due to this bond. So this is, if this is 30, this is almost 30. So we can see therefore our first x, the value of x will be this value which is here. We can see for example is 28 degrees, around 28 degrees. Then we have the other one, the other point of intersection, which is at this point here, this one here. So you also need to read this point here, this angle, and therefore we also have an angle like around 205 degrees. So that will be the solution for that. We have x equal to 28 degrees and 205 degrees. That is at the point of intersection. At the point of intersection is where we are going to have those values of x. So you need to be more accurate. Since you have the graph paper, you need to be very accurate to ensure that these angles are exact, because you are given a range of maybe plus or minus 0.1. So that's what we have. You read this point and this point, which are the points of intersection. This is a point of intersection. At the point of intersection, this curve is equal to the other. At the point of intersection, again, this curve is equal to the other. And therefore, that will give us the solution to that equation. 2 sin x minus cos x is equal to 0. So you can be able to solve more trigonometric equations by the graphical method. That is by drawing the two graphs or the graphs that you have been given. Then after plotting the graphs, you consider the equation and see how we can get the values of x, or the values. It can be 1, 2, or even more. So I'd like you to do this question. I'd like you to draw the following. Draw exercise. In this you are solving by the graphical method. Draw the graphs of y is equal to tan x and y is equal to cos x, y is equal to tan x for the values we have from negative pi radian. This is the same as negative 180 degrees up to pi radians, whereby we have from negative 180 to 180 degrees on the same axis, and use your graphs to solve. Tan x minus cos x is equal to 0. Then finally, number 2, draw the graph y is equal to sine 2x plus 30 degrees for the range 0 degrees all the way to 360 degrees. Then by including a straight line, use your graph to solve sine 2x plus 30 degrees is equal to 2x plus 30 degrees is equal to 0.8. So in all these questions whereby we are solving by graphical method, after plotting the graph, you need to apply the knowledge on quadratic equations, whereby you are plotting the quadratic curves and then using those curves to solve various equations. So you need to apply the same knowledge here, whereby like in this case, after plotting this, you now come and get the equation that you are trying to solve and see, is it a line that you are supposed to plot? Like in this, you are told that it is by including a straight line. So like if we may look at this part here, we have, in our equation, we have y is equal to sine 2x plus 30 degrees. And in this, we have sine 2x plus 30 degrees is equal to 0.8. So we have is equal to 0.8. So you can see these are the same. These and these are the same. And therefore, the graph that you are going to plot, or the line, is a line whereby y is equal to 0.8. So after plotting the curve, let's say you've plotted the curve. Now you need to come and have the line y is equal to 0.8. So where y is equal to 0.8, and then you read these points, where the point of intersection of the line and the curve, and these points will give you the solution. So ensure that you do that, and that has marked the end of this topic, trigonometry 3. That is on solution of trigonometric equations. Thank you. Have a good moment.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number and password. Click on sign up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Checkout Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Enroll your child with the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, we are here again today to learn about vectors. Now we've already had lesson 1 and lesson 2, vector 1, that is vector 1. Now in the last class we were able to look at addition of vectors. We were able to look at addition of vectors. We were able to look at subtraction of vectors and in essence what we call zero vector. And we were also able to look at multiplication of vectors by scalar quantities. Multiplication of vectors by scalar quantities. So this is the work we looked at last time. Today I want us to move ahead today and look at what we call column vectors. Column vectors. 2, we will look at very fast, again, position vectors. So we look at column vectors, we look at position vectors, and then lastly for today, we look at what we call magnitude of vectors. So this is the work we are going to look at today. Now I want you to realize, learners, that all these materials we are looking at, addition, zero vector, multiplication of vectors, column vectors, position vectors, and magnitude of vectors, everything in vector 1, we are actually looking at everything in vector 1 in what we call in 2 dimension. It is important to note this because we look at some of this information again when we'll be dealing with vectors in Form 3, and in that instance we'll be looking at these items in what we call 3 dimension. So I want us to start with column vectors. Now, it is important to know what to expect when we are talking of column vectors. Now, for example, when you want to give the value of vector xy like that, you can write the value of xy, say any numbers, 2, 3. Now, vectors written in this form, this vertical form, is what we normally say that a vector has been written in column form, and therefore these are the column vectors. So we can give several examples. For example, vector AB, you can write that as, say, scalar 1, 2. Now, it is important to note these are but examples. After our calculations, we can get different values, so these are but examples. Now, in each instance, I want us to realize that the first value at the top represents the x coordinates. The first value represents the x coordinates, and the second value represents what we call the y coordinates, the y coordinates. The first value represents the x coordinates, and the second value represents what we call the y coordinates. I want us to move ahead and see what we call column vectors when we look at a Cartesian plane. I want us to move ahead and look at what we call column vectors when we look at a Cartesian plane. Now, in a Cartesian plane, say that way, that will be y x-axis. So this is the y-axis. Always show the arrows and always write y-axis and x-axis. Don't assume. We can have a vector here, say vector GF. We can have a vector, say vector GF. Now in vector GF, we can give that arrow that way. I want us to get the coordinates of vector GF. Now, suppose this was 1, and here we have, say, 1, so that this can be 2, 3, 4, 2, 3, 4, 5. Now, it is important to realize we are not accurate. This is a sketch. Now, looking at this, for example, point G, point G is directly above 1 on the x-axis, and therefore you can give it coordinate 1 for x, and you put a comma there. And then it's directly next to 1 when you look at the angle between point G and 1 on the y-axis. There's a right angle. So you can say that the value of G on the y-axis is 1 again. Now for F, you can read it direct like that and say that F is directly above 4 in the x-axis. So the coordinate of F in respect to x is 4. You put a comma. And F is directly adjacent to 5 that way. So you give 5 there, give 5, give 5. So in other words, we can say that we are talking of vector G, F, where G has coordinates 1, 1, and F has coordinates 4, 5. Now, we've agreed that to get vector of these two places, to get vector of GF, then it means we are looking at the displacement between G and F, but in the direction from G up to F. So in that instance, we can therefore say that we look at the change in units of x axis. So at G, we are talking of 1, and at F, we are talking of 4, meaning the change between this G and F on the x-axis are actually 1, 2, 3 units. And therefore, we can therefore say that GF In respect to x-axis, we've had a change of 3 units. And in respect to y-axis, we can have change from 1 up to 4. So that will be 1 unit between 1 up to 2. The second unit between 2 up to 3. The third unit between 3 up to 4. And the fourth unit between 4 up to 5. So we can therefore say that from 1 up to 5 on the y-axis, we've had a change of 4 units. So the change in y-axis between G and F is therefore 4 units. Now, writing this, we can therefore write this vertically so that we end up with the point, the vector GF being 3, 4. In this instance, learners, we shall have written GF as a column vector. In this instance, we shall have written GF as a column vector. Allow me to give more examples so that we can understand better. Allow me to give more examples. So, like I've said, let me give you at least more examples to illustrate this. Now, you can be given 2 column vectors and asked, for example, to get the displacement between those vectors. For instance, you can be given vector AB and told that vector AB is 2, 3. Now, by now, I believe we already realized that this is a column vector. And you can also be given vector AC and told that vector AC is 1, 4. Now, from what we learned yesterday, addition of vectors, you can be asked to get vector AC. Now, getting vector AC in this instance, like we learned in the last class, we agreed that vector AC would be the displacement between A up to C. That is, you can have the vector A, B, C like that, such that vector AB, we already have, then vector BC, such that for us to get vector AC, we agreed it should be AB plus BC. So I'm bringing this forward so that we can see on how we can add column vectors. So in this instance, you will say that vector AB is given by column vector 2, 3, plus vector BC, this should have been BC so that it makes sense. BC would be 1, 4. Now, with this, we had agreed that the upper values, the upper scalar units, actually refer to the x units, and the lower scalar units, that is 3 and 4, actually refers to the y units. So in this instance, you will add the upper units on their own, so that will be 2 plus 1 to give us 3, and then 3 plus 4 to give us 7. Now, in the same breath, still you can be given column vectors and asked to subtract them. Still you can be given column vectors and asked to subtract them. For example, you can be given column vector 4, 9 and asked to subtract column vector 2, 6. So in this instance, like we've just said before, you will subtract the x units, that is 4 minus 2, and then you'll subtract the y units, that is 9 minus 6, like that, such that what you'll end up with is 4 minus 2 to give us 2, and 9 minus 6 to give us value 3. So in this instance, you've realized that we have used column vectors and applied it when it comes to subtraction and also addition of vectors. It is important still to know that column vectors is very useful when you are doing vectors, and still you can be asked to use it even during multiplication by scalars. For instance, consider, for instance, consider 2 vector AB minus 3 vector CD, where vector AB is 7, 14 and vector CD is 0. Let's not give it 0. Let's give it is, say, 1, 3. Now, in that instance, I am trying to refreshen our minds how we can apply multiplication of scalars to column vectors. We will end up saying that we now have 2 multiplied by AB, but AB here is 7, 14. Now, learners, let us begin. There are situations where learners have been putting a sign here, division sign. This will now not show a vector. This is a fraction. So whenever you are dealing with vectors, make sure that you just have a value of x units and also value of y units without any sign in between. So minus 3 vector CD, and CD there is 1, 3. Now I want us to be keen to see how we multiply when we are using scalars to multiply column vectors. So in this instance, we'll talk of 2 times 7. We'll multiply every individual letter, so every individual unit. So this will be 2 times 7, which is 14, 2 times 7. Then we'll have 2 times 14, which is 28. In other words, the vector 2AB now becomes 1428 minus 3 times 1, which is 3, and 3 times 3, which is 9. So from there, our subtraction is the normal subtraction, like what we've been doing before. So we will expect here to have 14 minus 3, which is 11, and then 28 minus 9, which give us 19. So that would be our answer for vector 2AB minus vector 3CD. So having looked at that, I think we've exhausted what you are supposed to look at column vectors, and we can look at what we call position vectors. So let me just clean here so that it's possible for us to look at the position vectors. Let me just clean all of it. Like that. Let me just clean there. So position vectors. Now in lesson 1 and lesson 2, we touched position vector a little bit, though we didn't go deep into it. But what we said is that position vectors start from the origin of a Cartesian plane. So for instance, if you draw a Cartesian plane like that, this is y-axis, and then this is x-axis. That is a 2-dimension Cartesian plane. We can draw, now we know this is the origin, so these coordinates are 0, 0. So all vectors starting from the point 0, 0 are called position vectors. For instance, you can have a vector like that to point, let's say this is origin O to point P. Let's give P the coordinates. Let's give P the coordinates 4, 5, where 4 is on the x-axis and 5 is on the y-axis. Now, with this, we can get what we call vector OP. As vector OP, we can get it. Now, since we've looked at column vectors, it now should be easy for us to get. Vector OP should be P minus O from what we have. And this is basically 4, 5 for P, 4, 5 for P, minus O here is 0.00. So when we look at this vector, therefore, we can say that vector OP is equal to 4, 5. Now, vectors that start from the origin O are normally called position vectors. So in this instance, vector OP here is a position vector, and normally we simply represent position vectors by the last alphabet. For example, if it is OP, you simply call it vector P using small p instead of writing OP. So instead of saying vector OP, we can simply say we have vector P, this is small p, is equal to 4, 5, which is column vector of position vector P. Now, in general, therefore, let's just rub here. In general, therefore, we can boldly say that anytime you have any position vector, say OB, then you can write its position vector as vector B. If you have, say, OD, then its position vector is simply vector D, small d. If you have, for instance, OW, then its position vector is simply W, like that. I want you to try a small assignment later. If you're given, say, vector OJ, I want you to tell me what will be its position vector, letter that will represent it. You're given OQ. I also want you to tell me a letter, how you'd represent it using only one letter. Only one letter. Now, when you're talking of position vectors, the coordinates of the last point is normally important. For instance, in this case, vector OP, we went the long way, but since at the origins there's 0, 0, normally you can just pick the last coordinates, write them in column form, and that will give us what we call the position vector of that number. So having looked at that, I think we can move straight away, because this knowledge of position vectors and column vectors will be important in the next thing we are going to learn. So I want us to look straight away at what we call the magnitude of a vector. 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 So we can do that. Now, we agreed when we were starting the first lesson that whenever you're talking of magnitude of a vector is the same as looking at the length of that vector. The magnitude of a vector is normally the same as looking at the length of that vector. Now, I want us to consider a point. Let's say this is y-axis, this is x-axis. So that is y-axis and that is x-axis. I want us to consider a point, say point EF, those 2 points, and let's say this is a vector. Now, from these 2 points, I want us to talk of the coordinates. Let's give them coordinates. we can give them coordinates of E2, 3. Can give them coordinates of E2, 3. And F, let's give them coordinates of, let's give F the coordinates of 5. Let's give X the coordinate of 5, 7, that way. Now, looking at this, we know that we can get the length EF. But how we can get the length EF, it means that we can create a right angle triangle like that. Now, on creating a right angle triangle, this means that if this is 2, 3, it means that this point we are talking of 2, and at this point we are talking of 5. And then at this point, if we have 2, 3, it means we are talking of 3, and at F, it means that the y value there is 7. Now, from this, remember, it is this magnitude we want to get, and we've just agreed that magnitude is the same as length. So to get this magnitude or the length between EF vector, we know from our knowledge of triangles that we can use a formula called Pythagoras theorem. Allow me to wipe here so that it is clearer to us. We know that we can use a formula called Pythagoras theorem so that we can get EF. Now, that theorem states that if, now let me call this point arbitrary point, say EX, let me call here X for the purposes of understanding what we are doing. Now, that formula tells us that if we take EX and square it and add XF, we add XF and square it, then the length we are getting would be the same as the length EF squared. Now, with that in mind, therefore, we can get EX. Now, EX in this instance are the displacement in the x-axis. Now, the first value of x is 2, and the last value on the x-axis is 5. So we've had a displacement of 3 units. So in this case, we can therefore call EX as 3 squared plus. Now, the first value of E at y-axis is 3, and the last value is 7, meaning we've had a displacement of 4 on the y-axis, and call this 4 squared. So while working with that, we can therefore get EF squared like that. Now we know the value of 3 squared, so this will be 9 plus 4 squared would give us 16, and this should be EF squared. So from here we can get 9 plus 16, which is 25, which is EF squared. It is important to realize you can start by writing EF squared is equal to 25. So to remain with EF alone, if we originally have EF squared, we can find the square root of both sides like that, such that EF squared will be EF is equal to what we are now calling 5 units. So this will be the magnitude. Now, normally when you are talking of magnitude, you denote magnitude of a vector. Say, in this instance, we wanted magnitude of vector EF. Normally, we denote magnitude of a vector by double straight vertical lines next to it, such that you create 2 lines here like this. So when you do this, you can say this is 5. So this is read as magnitude of vector EF. Magnitude of vector EF. It is also important to note that magnitude can sometimes be called the modulus the modulus. So we can call this the modulus of vector EF, or we can call it the magnitude of vector EF. Now, learners, I want us to realize something. We were initially dealing with EF as EF, and we gave the coordinates of E as 2, 3, and the coordinates of F we gave as 5, 7. It is important to know that we can get the magnitude of this without actually drawing anything on the Cartesian plane. So while working with this, first of all, for us to get the magnitude of vector EF, it will be important to get vector EF alone like that. So vector EF is the displacement between E and F. So we can use the column vectors and say this is F, which is 5, 7, minus E, which is 2, 3. From here, we can say that we will have 3, 4. Can have 3, 4. Now, from this, we can therefore say that EF modulus, the magnitude of EF, can therefore be the square root of 3 squared plus 4 squared, like that. Such that from this, we can therefore say that the magnitude of EF is equal to the square root of 25, which will give us the magnitude as 5 units. Can probably give you another example, and then from there we can now give you an assignment. Suppose you are given vector CD as 2, 7. Suppose you are given vector CD as 2, 7, and you are asked find the magnitude of CD. Then you will simply say that the magnitude of CD is equal to the square root of 2 squared plus 7 squared, which will give us the square root of 4 plus 7 squared is actually 49, which will give us the square root of 53. So from here you can use your calculators to find the value of the square root of 53. I therefore want us on finishing to leave work behind so that you can have some assignment to do. So this is the work I want you to try later so that you can check whether you are able to understand what we have done. Assignment. Find the magnitude of AB, where A, vector A is 2, 1, and B is 4, 5. B, where A is negative 3 and the Y value there is 0, negative 3, 0, and B is 0, 4. So that is the first question. Question 2, find the magnitude of the following vectors. magnitude of the following vectors. So the first vector in this case should be vector AB 6, 5, and vector XY, you can work with 12, 13. So that brings us to the end of our lesson today. You'll do that assignment so that you can test yourself. Now you realize that our assignment is on magnitude, though we've worked on column vectors, we've also worked on position vectors. It is important to realize that the column vectors and position vectors are actually applied in the magnitude of vectors. So in essence, the practice we are doing here is actually still making you to do practice on column and also on position vectors. I want us to stop there for today. So we have to remember: 1, we've learned about column vectors; 2, we've learned about position vectors; and 3, we've learned about what we call magnitude, or the length or the modulus of a vector. I have been with you, Mr. Geoffrey Omondi. Allow us to stop there for today. Till next lesson. Thank you.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Checkout Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the Manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform. We are learning chemistry from 1 and the topic is simple classification of substances. In our today's lesson, we are discussing separation of soluble, solid, liquid mixtures. If you remember in the previous lesson, we were discussing how you can be able to separate copper 2 sulfate from a mixture of copper 2 sulfate and water. And we say that the method you can use is crystallization, where you put the mixture on an evaporating basin. You put this evaporating basin containing the copper 2 sulfate solution on a water bath and heat until crystals start forming. Once the crystals start forming, then you remove the evaporating basin on the water bath and cool, because once the crystals start forming, we say that solution has already become saturated and it can form crystals. A saturated solution, we said it's a solution where no more solute can dissolve at a given temperature. No more solute can dissolve at a given temperature. That is what we call a solution. Therefore, this method of separation, we call it crystallization, and we said it can be applied in so many other areas. And some of them, which we said that it can be applied in extraction of salt from salt water, like in Magandi and Ngomeni in Malindi. Second, it can be used in extraction of sugar from sugarcane. Third, it can be used in extraction of medicinal substances from plants. That is what we discussed in the previous lesson. And I left with the assignment of describing how you can be able to separate a mixture of, a mixture of copper 2 sulfate and water. How can you be able to obtain copper 2 sulfate from a mixture of copper 2 sulfate and water? In this lesson, I want us now to do a separation of sand and sodium chloride. How can a mixture of sand and sodium chloride be separated? Therefore, separation of sand and sodium chloride. Do you know how they can be separated? Maybe yes or no. But this is how you can be able to separate the two. One, you need to put the mixture of sand and sodium chloride in a beaker. So once you put them in a beaker, so that you add water. Add water and stir. Add water and stir. Then, when you stir, sodium chloride dissolves, while sand does not dissolve. Sodium chloride dissolves in water, while sand does not. Therefore, filter the mixture to obtain sand as a residue and sodium chloride solution as a filtrate. Filter the mixture to obtain sand as a residue and sodium chloride solution as the filtrate. then evaporate or carry out evaporation on sodium chloride solution to obtain sodium chloride salt. That is how you are able to separate them. So step number 1, put the mixture in a beaker. After putting the mixture in the beaker, then you add water to the mixture and you stir with a stirring rod. Once you stir the mixture, then sodium chloride will dissolve in water while sand will not dissolve in water. Therefore, what do you do next? You carry out filtration. Carry out filtration. And when you carry out filtration, then sand will be the residue and sodium chloride solution will be the filtrate. Then this filtrate, if you want now to obtain sodium chloride from the filtrate, then you just need to evaporate sodium chloride solution to obtain sodium chloride crystals or sodium chloride salt. Maybe in form of a diagram. This is how the diagram will be. So if you had a mixture of sodium chloride and water, you added water to dissolve sodium chloride and sand will not dissolve, then you now carry out filtration process. Then when you carry out filtration, then remember this is the filter paper. This is the filter funnel. Then in our case, this is what we are calling the residue. The residue in this case is now sand. What passes through is now sodium chloride solution. Sodium chloride solution is obtained as the filtrate. This is the filtrate. The filtrate is a solution of sodium chloride. Remember, when we talk about a solution contains a solute and a solvent. Therefore, in this solution, we have sodium chloride, solute, and water. That is now what is forming that solution. That is now the first step. You will now have separated sand from sodium chloride. You'll have separated sand from sodium chloride. Now the next thing, you want to obtain sodium chloride. You want to obtain sodium chloride salt. Therefore, you have seen that you just carry out evaporation of sodium chloride. And therefore, the second step will be that is what we are going to do in the second step. You have the water bath, you have the solution of sodium chloride, there is the evaporating basin, then there is heat. You're heating. The heat is now coming from a Bunsen burner flame, preferably non-luminous flame. Then once you heat it, then water is now going to evaporate. You are going to be left with sodium chloride solution. Sodium chloride salt. Then you will now have obtained sodium chloride from this one. and you'll have now separated, you will have removed sand in the previous experiment or the previous step. And therefore, to separate sand and sodium chloride requires a combination of two methods. To separate sand and sodium chloride, we use two methods. The methods are filtration and evaporation. Therefore, to separate sand and sodium chloride, filtration and evaporation methods are used. To separate sand and sodium chloride, filtration and evaporation methods are used. Therefore, this is filtration and this is evaporation. Filtration is used to separate sand and sodium chloride solution. And evaporation is used to separate sodium chloride and water. Then you'll now have obtained each separately, and you will have achieved the objective of separating sand and sodium chloride. It is that easy. Maybe now to do a repetition or to repeat what I've said, the first step was to put the mixture in a beaker. Once you put the mixture, and remember the mixture is sodium chloride and sand. Sodium chloride and sand. When you put them in the beaker, you add water. You add water and stir. When you stir, sodium chloride is going to dissolve while sand does not dissolve. Therefore, you now carry out filtration. When you filter, sand will be the residue while sodium chloride solution will be the filtrate. Therefore, using filtration method, you've separated sand and sodium chloride solution. Therefore, what's left? It is now to separate sodium chloride from a mixture of sodium chloride and the water. And therefore, which method are you using? You're using evaporation method. You are going to evaporate excess water from sodium chloride, and then you'll be left with sodium chloride crystals. That's how simple it is. Therefore, that brings us to the end of our lesson today. But before I end, I will leave you with this assignment. And the assignment is describe how a mixture of sand and sodium chloride can be separated. Therefore, ensure that you've done that question before we meet in the next lesson, which we are going to do separation of another soluble solid liquid mixture. See you in the next lesson.
Welcome to Manifested Publishers.
Hi, my lovely learners. I am so excited to have you again for this lesson. I am Teacher Purity, and remember, this is still Manifested e-learning forum. So we are still continuing with our topic on personal hygiene, and we are going to learn about care of personal items. And we are going to start with care of a handkerchief. Now, during our previous lesson, we learned about how we can make personal items. Making personal items is using the materials that are available. Now, we say that you can make a toothbrush from a chewed stick. So a chewed stick can be used as a toothbrush. We can also make a handkerchief from an old piece of cloth. We can make a handkerchief from an old piece of cloth, and make sure that you clean the piece of cloth, let it dry, then you cut a small piece of it. Then we can also make a face towel from an old piece of cloth. So a toothbrush, a handkerchief, or a face towel, it's not a must for you to go and buy it from the shop or the market. You can still use the old pieces of cloth at home to make them. So today we are going to learn about the care of personal items, and we shall start with the first one, which is a handkerchief. Care of personal items. This one means how you are supposed to clean the items that you use at home, the personal items that you have. For this case, we shall start with a handkerchief. Now, a handkerchief is a personal item that we use to clean our nose. So we use a handkerchief to clean our nose. We use a handkerchief to clean our nose. When your nose is dirty, you are going to use a handkerchief. Now, this handkerchief is also used when you are sneezing. You cover your nose using a handkerchief when sneezing. So we cover our nose with a handkerchief when sneezing. So we cover our nose with a handkerchief when sneezing. When you are sneezing, make sure that you are covering your nose using a handkerchief. Now, for instance, I have my handkerchief here. When you are sneezing, you are supposed to hold your handkerchief like this and cover the nose, cover the nose with it like this. Why are you covering the nose with your handkerchief? To avoid contraction of germs by other people. So we cover our nose with a handkerchief when sneezing. Another thing, do not blow your nose using fingers. So do not blow your nose using fingers. The work of a handkerchief is to help us to clean our nose. So when blowing your nose, make sure that you are using your handkerchief and not your fingers. You cannot blow your nose using your fingers. Make sure that you are using the handkerchief. Why are you using a handkerchief? Now, when you use the handkerchief, you are preventing the spread of germs to other people. So we use a handkerchief to prevent the spread of germs to other people. We use a handkerchief to prevent the spread of germs to other people. So we use a handkerchief to prevent the spread of germs to other people. When you cover your nose, your germs are not going to spread to other people. It will already have been prevented by the handkerchief. So make sure anytime that you are blowing your nose, use your handkerchief. Anytime that you are sneezing, you can use your handkerchief to cover the nose. Or if you do not have a handkerchief, cover your nose with an elbow. So the work of a handkerchief, number one, we use a handkerchief to clean our nose. The handkerchief is what we use to clean our nose. Number two, we cover our nose with a handkerchief when sneezing. If you have a cold or flu, you can sneeze, and therefore during sneezing, make sure that you are using a handkerchief. Number three, do not blow your nose using fingers. Blowing your nose is when you are removing mucus from the nose. So do not use your fingers when blowing the nose. And lastly, we use a handkerchief to prevent the spread of germs to other people. That is the reason why we are using a handkerchief, to prevent the spread of germs to other people. Always remember that you are not supposed to share a handkerchief. A handkerchief is a personal item. Remember, personal items are not supposed to be shared. So it is the same with the handkerchief. Your handkerchief cannot be used by any other person. Neither can you use another person's handkerchief. So these are the uses of a handkerchief. Make sure that you master them. In our next lesson, I shall teach you on how we clean the handkerchief. Make sure that you attend and come with your handkerchief so that we can be washing along. Meanwhile, I'm going to give you an assignment. Copy the questions in your exercise book and make sure that you answer them. So the assignment, number one, write down 3 uses of a handkerchief. So you write for me the uses of a handkerchief in the blank space A, B, and C. And question 2, draw and color a handkerchief. You'll draw and color for me a handkerchief. So copy the questions and make sure that you are answering them. And after finishing to answer your work, go through it just to check if there is a mistake that you've committed or something that you have left out. So hope to see you in the next lesson. Have a wonderful time.
Welcome to Manifested Publishers.
Hello, my beloved learner. Welcome to our today's lesson. I am honored and I am glad that you have joined me in this lesson. We are going to have a history and government lesson, and we proceed with studying the topic European colonization of Africa and their invasion of Africa and the process of colonization. That is the topic European invasion of Africa and the process of colonization. And in our previous lessons, we have been learning about the African reaction, how the Africans reacted to the process of European colonization. In our last lesson, as you can remember, my dear learner, we started analyzing the Baganda collaboration, how the Baganda collaborated with the British in their land, the agreements they made. We looked at the causes, the reasons for their collaboration with the British. And you remember we mentioned the different kings who at the time were referred to as the Kabaka. So Kabaka Mutesa I was the first person to collaborate or invite the British and make a kind of an agreement with them. He wanted protection from his enemies, the arch rivals, community that had been fighting against the Baganda, which was the Bunyoro. He also wanted to retain his independence or his rulership. And also, we also knew that he wanted to counter the spread of Islam that had really taken root in the Baganda kingdom as a result of the long distance trade. So, my dear learner, in our today's lesson, we are going to look at the terms of the Baganda Agreement or the Baganda Agreement of 1900, which was made between the British and the Kabaka at that time, Kabata, and the leader at that time, who was Apollo Kagwa, and that happened after the death of the second the Kabaka Mwanga, who tried to revolt against the British, and he was able to be defeated. He could not effectively revolt against the British, so he had to run away. I'm just trying to remind us what we learned in our last lesson. So he was able to run away from the British, but he was captured and then he was deported to a place or to another country. Which city, which place was he taken to when he was captured? Yes, very good. He was taken to Kismayu. And then after that, he was also taken to Seychelles, where he died. So after his death, his son, who was an infant at that time, Daudi Chua, took over the reins. But because he was only a child, an infant, he could not be able to make decisions. So the three leaders at that time, who were the Katikiro at that time, the Katikiro was the office of the prime minister. It was known, that office was known as the Katikiro, together with the chief justice, who was, you can remember, we did not mention, but in your Form 2, you remember you refer to him as the Omulamuzi, right? And then we had, apart from the chief justice, we had the Katikiro, who was the prime minister, and then we also had the treasurer, who took the reins. So these three, the Katikiro was the most powerful at that time, was known as Apollo. Apollo was known as Apollo Kagwa. So he made an agreement with the British that came to be known as the Baganda. Let me write here, Baganda Agreement. The Baganda Agreement. So the Katikiro at that time, who was known as Apollo, made this agreement with the British. So it was an agreement. It was an agreement between the British. It was an agreement between the British and the Baganda. It was an agreement between the British and the Baganda. It was made in the year 1900. That's a very famous time, because the British and the Baganda became into, or made an alliance or an agreement. So the British were represented by Harry Johnson. Let me check that I have gotten Johnston. It is Johnston. Harry Johnston. While the Baganda were represented by Apollo Kagwa, who was at that time the prime minister or the katikiro of the land. So they made an agreement, both of them, concerning how they are going to run the affairs of the kingdom. So these agreements, let us look at the terms. The terms of these agreements were made in three parts. So the terms of the agreement were divided into three parts. That is concerning the land, that is number 1, or Roman 1. Let us call it Roman 2. Concerning the government, the first way in which the first term was concerning the land, the second one was concerning the government, and also the third one was concerning the boundaries. The boundaries. And then number 4, it was concerning the finances. The finances of the kingdom. So we are going to look at the terms. In our lesson, we are going to look at the terms that were made in the Baganda Agreement. So we are going to look at the terms. The terms of the Baganda Agreement. And we said it was made in 1900. And I've mentioned these terms were based in 4 arms or in 4 parts. Terms concerning land, terms concerning the government, terms concerning the boundaries, and terms concerning the finances of the kingdom. So let us start with number 1, the land. So let us start with land. Let me use a different color so that you are able to differentiate. So let us start with the land. So the land of the Buganda was divided into 2. The land was divided into 2. So this is the first term. The land was divided into 2. The first half. The first half. The first half was declared the crown land. The first half was declared the crown land. These belonged to the British government. It was owned and directed by the British government. So if you wanted to have a portion or occupy it, it was on tenancy terms. So if you are to occupy the crown land, you had to pay some amount as a tenant to occupy that land. And then the second half was divided among we had the Kabaka took a portion of it. We had Kabaka, and then the 3 ministers or the ministers at that time who are recognized. We had the prime minister or the katikiro. We also had the chief justice. We also had the chief treasurer, right? And then we had the chiefs. The chiefs also had become very effective people. Remember, the kingdom was divided into sazas. So every saza chief was allocated a portion of land, and then members of the royal family, members of the royal family were the other people who were allowed to get land. So that is concerning land. That was the first, or these were the first term. So the first term was that the land was to be divided into 2. half was known as the crown land, and then the second half was given to the officers that were running the government. So that was the first thing. Now let us go and look at the second part, which is the government. What terms or were made? What terms or agreements were made concerning the government? What terms were made concerning the government? So Kabaka, so we can say this is, we can consider it the third, or let me just name it one so that you are able to follow very well. The first term concerning the government, Kabaka, recognized as the king or ruler of the kingdom. Kabaka was recognized as the ruler of the, or the king of the kingdom. So his power was recognized, or his position was recognized as the leader, though he had limited powers. And then number two, his government. His government would not do anything against the protectorate, government. The government, or the Kabaka's government, would not do anything against or contrary to the protectorate government. So everything had to be directed or under the stipulations of the government. And then there was the official recognition. There was recognition of the prime minister, who was referred to as Katikiro. His office was known as, and then we have the Chief Justice, and also the Treasurer. So these offices were recognized as part of government. And then also the Lukiko, which was the law-making arm, or the advisory to the Kabaka, was officially recognized as the legislature, and final court of appeal. So the Lukiko, which initially was the advisory body to Kabaka, was now officially recognized as the legislature of the kingdom, and also it was supposed to act as the final court of appeal. So if you had a case as a member or as a person in the kingdom, the last place you could go and appeal your case was in the Lukiko. And then lastly, there was supposed to be a Britain or a British resident. A British resident was to be stationed in the kingdom. A British resident was to be stationed in the kingdoms. What was the purpose of this? To make sure or to safeguard the desires or to safeguard the interests of the British government. So that was his role. There had to be a British resident who was supposed to be stationed in the kingdom, for the purposes of safeguarding the desires of the British government. Now, my dear learner, we have looked at the land. We have looked at the land, the laws made or the agreements that were made concerning the land. We have looked at that. Then we have looked at the agreement that was made concerning the government. Now, let us look at the laws that were made concerning the boundaries. The boundaries. My dear learner, what agreement was made between these two? Remember, we are talking of an agreement that was made between the British and the Buganda, between Harry and Apollo. So what did they agree concerning the boundaries? So the Buganda kingdom, it was a kingdom on its own. So it was recognized. The Buganda or the Buganda was recognized as a kingdom that is self-sufficient, that could stand on its own. And then number two, its boundaries. Its boundaries would involve or would extend to Bunyoro kingdom. So its boundaries were expanded up to Bunyoro kingdom because now the British helped them overcome the Bunyoro Kitara kingdom. So that is about the boundaries. So these are the agreements. Buganda was now recognized by the British to be a kingdom on its own with a king and leaders, the ministers who were the prime minister, the chief justice, and the treasurer, and also the Saza chiefs, right? And then the boundaries were expounded, or they were expanded or extended. Now, let us look, we have looked at the boundaries. Now, let us look at the finances. So, number 4, let us look at the finances. Let us look at the finances. What agreements did the two parties, remember an agreement composes of two parties, what agreements did they make concerning the finances? Now, there was introduction of a hard tax. Introduction of a hard tax of 3 rupees. There was introduction of a hard tax of 3 rupees. Each and every person was supposed to pay a hard tax, right? And then there was also another kind of tax that was known as the gun tax. Any person who owned a gun, he was supposed to pay tax. And then Kabaka, we said that Kabaka was able to Kabaka and the ministers, the Kabaka, the ministers, and the chiefs would be paid for their services. The work they were doing in the kingdom or in the protectorate, the Ugandan protectorate, it was being recognized by payment, right? And then there was a restriction. There would be no further taxation without consulting the Kabaka and Lukiko. So the British were restricted in this agreement. The British were restricted. They would not tax or impose any further tax without first consulting with Kabaka and also with Lukiko. And then finally, my dear Lana, all revenues to go to protectorate government, all the revenues in the kingdom, all the revenues in the kingdom to go or to be channeled to the protectorate, government. All the revenues were to be channeled to the protectorate government. So, my dear Lana, these are the terms that these two groups, we have talked of finances now, these are the terms that these two groups made. They made terms on land, made terms on government, made terms on boundaries, and also on finances. So, if you are asked a question to describe or outline the agreement that were made, in the Buganda Agreement or the Baganda Agreement of 1900. You should not forget that. It was made in 1900. These are the terms that they agreed upon, both the British and the Baganda. So, as we come to the end of our lesson today, I want to give you, my dear Lana, a brief a revision question. A revision question that you can attempt. A revision question that you can attempt to help you partake. So let us look at a revision question. Look at the revision question. Revision question. And the question is, my dear Lana, identify the terms of the Uganda Agreement. Of 1900. Identify the terms of the Uganda Agreement of 1900. And with that, we have come to the end of our history lesson. I hope you have had a nice time. You have enjoyed learning, or you have learned a new thing concerning the terms of the Uganda Agreement. So until the next time we shall meet, it's bye-bye for now.
Welcome to Manifested Publishers.
Hello learners, welcome to today's biology lesson, Form 3. My name is Stephen Kariungi, and we continue with our topic of discussion, which is sexual reproduction in plants. So today we are going to discuss pollination. So the first thing that we ask ourselves is, what is the meaning of the term pollination? The term pollination comes from the word pollen. So that means that it involves pollen. So we can say that pollination is the transfer of pollen grains from the anther to the stigma. Pollen grains are produced in the anther, and they need to be transferred to the stigma during pollination. So we can say that this is the transfer of pollen grains from the anther to the stigma. Now, we have two types of pollination. Types of pollination. The first type of pollination, we refer to it as self-pollination. And self-pollination is whereby the transfer of pollen grains is from the anther to the stigma of the same flower or of another flower within the same plant. So basically in self-pollination, we don't move outside one plant. So it's either from one flower to another flower within the same plant or from the anther to the stigma of the same flower. So we can say that this is the transfer of pollen grains from anther to the stigma of the same flower or another flower within the same plant. So we are saying that self-pollination is the transfer of pollen grains from the anther to the stigma of the same flower or another flower within the same plant. So basically, we don't move outside that particular plant. The other type of pollination is what we call cross-pollination. And this is the transfer of pollen grains from the anther. It has to be always from the anther to the stigma. Of another flower in another plant. So this one has to be in another plant, but of the same species. So basically, cross-pollination, there is the transfer of pollen grains from the anther to the stigma of another flower in another plant, but that plant must be of the same species. So it has to be from this plant to another plant of the same species. So that is what we call cross-pollination. Now, in cross-pollination, we can say that there is mixing of genes because one plant is not completely identical to the other. So in this case, there are some small variations that exist in terms of their genetic makeup. So in this case, we can say that cross-pollination leads to exchange of genetic material which leads to variation. So this is one of the sources of variation, or this is one of the causes of variation. When there is mixing of genetic material between different plants of the same species, then that brings about what we call variation. Now, the other things I want us to discuss are the agents of pollination. Note the difference between the types of pollination and agents of pollination. The agents of pollination are the ones that aid the movement of pollen grains from the anther to the stigma. These agents can either be animals, for instance, insects. Insects are the main animal agents of pollination. Or another agent of pollination can also be wind. So mainly there are those two. So two main agents of pollination are insects and wind. So we are going to look at what are the adaptations of insect pollinated flowers. What are some of the features that they have so that the insects become the agents of pollination, to attract these insects so that they can come and help in the transfer of pollen grains. So we look at the adaptations of insect pollinated flowers. And those insect pollinated flowers, we also refer to them as entomophilous. Entomophilous flowers. We know that entomology is the study of insects. So for those flowers that are pollinated by insects, we refer to them as being entomophilous. Now, one of the features that you'll observe in these insect pollinated flowers is that they usually have very large petals, very conspicuous. You can see them from a distance. And they are usually brightly colored. So you can say that one of the adaptations is that the petals are large, conspicuous, and brightly colored. To attract insects, which are the agents of pollination. So when they are large and conspicuous, the insects can easily see them from a distance. When they are brightly colored, the insects can also be able to see them from a distance. Number two is that they are usually scented. That is, have scent that attracts insects to them. So the insects are attracted also by the scent that is produced by these flowers. The other thing about the insect pollinated flowers is that they have small anthers that are located within the flower. They have small anthers that are located within the flower and produce a relatively lower number of pollen grains. So the number of pollen grains that are produced here, they are not so many because there is minimal wastage. There is minimal wastage. Also, we are saying that the anthers are small and located within the flower. So chances of these anthers losing the pollen grains are minimal. As for the pollen grains themselves, the pollen grains are large. They are relatively large and sticky. They are large and sticky to attach or to allow them attach on the insect's body. On the insect's body. So they are sticky so that they can attach onto the insect's legs. They can attach onto the insect's wings as they are being transferred from one point to the other. These insect-pollinated flowers also have nectaries that produce nectar. And this nectar is the one that attracts insects. The nectar attracts insects to feed on them. Feed on them. So the nectaries produce nectar that attracts the insects. Number 3, these flowers are usually funnel-shaped. They are funnel-shaped, forming a landing platform. So that the insects can be able to land on them, forming a landing platform for the insects. So basically, those are some of the adaptations of the insect-pollinated flowers, such as hibiscus and most of the commonly seen brightly colored flowers. So you've seen that the petals are large, conspicuous, and brightly colored to attract the insects. They are usually scented, or they have scent that also attracts the insects to them. They have small anthers located within the flower and produce a relatively lower number of pollen grains because there is minimal wastage. The pollen grains are large and sticky so that they can be able to attach on the insect's body when they are being transported. They have nectaries that produce nectar, and that nectar attracts the insects to feed on them. And finally, we've seen that their shape is funnel-shaped, that is wider at the top and smaller at the base, and that is to form a landing platform for the insects during pollination. So we'll stop there for now, and then we look at an assignment on the same. So the first question, what is pollination? Second question, name the 2 types of pollination. And number 3, state and explain 5 adaptations of insect pollinated flowers. So we are going to stop there for today. Goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. I welcome you to today's biology topic of discussion, and we are discussing transport in animals. So specifically, the area of our discussion is the structure and function of blood capillaries. So this will be number 2 because our last lesson we discussed the structure and function of the arteries. And one thing about the capillaries is that they are the sites for exchange of nutrients, oxygen, and metabolic wastes between the blood and the tissues. So basically the capillaries are the ones that reach the farthest tissue in the body, and they are the areas of exchange. So the arteries bring blood that has nutrients and oxygen, and that blood supplies the tissues. And then the tissues release metabolic wastes into the capillaries, and then the capillaries transport. So we are saying that there is an exchange that occurs between the capillaries and the tissues. So we are saying that capillaries are the blood vessels that reach the farthest tissue in the body. And also they provide a site for exchange of oxygen and nutrients from the blood and metabolic wastes from the tissues. So it is important to also look at the structure of a capillary. So we have the structure of a capillary has a lumen through which the blood flows. The wall is known as the endothelium, and it's 1 cell thick. It's 1 cell in thickness, as you can be able to see. So the wall is very thin. The wall of a capillary is very thin so that there is proper exchange. So in this case, you can look at the adaptations of an artery, and the most important thing is that it is 1 cell thick, 1 cell in thickness, to allow exchange of materials between the blood and tissues by a process called ultrafiltration. So that wall is thin so that there is easier exchange of materials across the wall between the blood and the tissues, of course by ultrafiltration. The other adaptation is that the capillary has a narrow lumen to maintain a high pressure, for ultrafiltration. So that high pressure that is built up at the capillary is the one that allows materials such as nutrients and oxygen to diffuse from the blood into the surrounding tissues, and metabolic wastes from the surrounding tissues to the capillary. So basically that is the structure of the capillary. And basically it's also good to mention that many organs in the body are supplied with blood by numerous blood capillaries, to increase the surface area, for the exchange of materials that we have mentioned. So when there is numerous blood capillaries, then there is a large surface area for the exchange of materials that takes place in those parts of the body. So we'll now have an assignment on the capillary. So the first question in the assignment, draw a well-labeled diagram of a capillary. 2, state 2 adaptations that enable the capillary to function effectively. So we'll stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to our today's biology lesson. Today we are discussing biology form 1 and the topic is introduction to biology. My name is Stephen Kariungi. Now, in our previous lesson, we introduced the branches of biology. So today, we are going to look at how is biology important in our day-to-day life. So basically, we look at the importance of biology. Now, one of the importances of biology is that biology is a career subject, is a subject that is applicable in many different careers, such as medicine, such as environmental conservation, public health, veterinary medicine, and so many others. So basically, all those careers, they need or they require biological knowledge for you to be able to excel. So biology is a career subject that prepares learners for the study of medicine, public health, veterinary medicine, etc. So that is basically one of the importances of biology as a subject. Number 2 is that biology helps to solve environmental problems. Biology helps to solve environmental problems such as pollution, food shortage, etc. Number 3, biology also helps us to understand the development of the human body, Number 4, also biology equips the learner with scientific skills such as observation, analysis, evaluation, and so on and so forth. So it equips the learner with scientific skills e.g. observation, evaluation, analysis, etc. This is through the undertaking of various biological experiments and practicals. Biology is also important in international cooperation. It's important in international cooperation in dealing with challenges such as HIV/AIDS, global warming, etc. And that is something that brings various nations together when they are dealing with challenges that affect many countries or that affect the entire globe. So basically, those are some of the importances of biology or why the study of biology is important. The other thing that we are going to learn is the characteristics of living organisms. For us to understand biology better, it is important that we know which characteristics are common in living organisms. And I want us to use an acronym. And this acronym is Mrs. Gren. In order to understand the characteristics of living organisms, we can use the acronym Mrs. Gren, written downwards, and each of those letters has a meaning. For example, the first letter M represents movement. Then respiration, sensitivity, growth, and development, they go together. There is reproduction, excretion, and nutrition. So those characteristics, they are found in all living organisms. Living organisms move either from one point to another or move part of their body. They respire, they show respiration, they show sensitivity, maybe sensitivity to temperature when it is too cold or too hot. They show growth and development with time. They reproduce, that means they produce some young ones. They excrete, they produce waste products, and they acquire nutrients. That is what we call nutrition. So we are going to look at what each one of those characteristics means and why it is important. So we'll start with the first one, and this is movement. And we say that this is the displacement of part of or entire body. So organisms are able to displace part of or their entire body, and that's what we call movement. We have also respiration, and this is the breaking down of food to obtain energy. We have sensitivity, and this is the ability to detect and respond to changes in the surroundings. We need to be aware of our surroundings. Number 4, we have growth and development. And we can define the two separately. Growth is the irreversible increase in size and mass. Organisms are able to grow by increasing their size and also mass. And then we have development, which is the change in complexity of the organism. How an organism becomes more and more complex with time. Number 5, we have reproduction. And reproduction is the ability to produce offspring of their own kind, ability to produce offspring or young ones of their own kind, we have excretion, the ability to remove metabolic wastes, from the cells, and then finally nutrition, which is the ability to acquire and utilize nutrients in the body. So basically, we have seen the 7 characteristics of living organisms, and we have also studied the importance of biology. We have studied that biology is a career subject, and we have seen careers where it is applicable. Biology is important in solving of environmental problems. It gives scientific skills to the learner, such as observation, classification, analysis, and so on. Biology is important during international cooperation between nations while dealing with the challenges such as HIV/AIDS, global warming, and so on and so forth. Then finally, we have looked at characteristics of living organisms, which we have summarized as follows. The acronym is Mrs. Gren, M for movement, respiration, sensitivity, growth and development, reproduction, excretion, and nutrition. Then we have defined each one of those terms. Movement is the displacement of part of or the entire body. So movement does not have always to move the entire body, but also can be part of the body. Respiration, ability to break down food to obtain energy. Sensitivity, ability to detect and respond to the changes in the surroundings. Growth and development. Growth is the irreversible increase in size and mass, while development is the change in complexity of the organism. Reproduction, ability to produce young ones or offspring of their own kind. Excretion, the ability to remove metabolic wastes, and specifically metabolic wastes from the cells. And then finally, nutrition, the ability to acquire and utilize nutrients in the body. So basically, that is what we have covered today. So we'll have a short assignment covering what we have learned. So the first question, give 4 importance of biology. Number 2, define the following terms. The first one, A, is sensitivity, B, movement, and C, growth. So we'll stop there until next time. See you then.
Welcome to Manifested Publishers.
Hello students, welcome to Manifested e-learning platform. My name is Wilson Andove and I'm your literature teacher. Now, some of you are wondering, what is literature? Literature is actually what I'm sure most of us have gone through. When you read a story, when you read a poem, or when you see people acting on stage. That's literature. Some of us might have read a novel by Ngugi wa Thiong'o called The River Between. That is an example of what we call literature. We have many other stories or many other novels, examples by Chinua Achebe called Things Fall Apart. Such a novel is what we call literature. So literature actually means any form of art, mostly that which is written down and uses language in a very special way is defined as literature. So we can begin by defining the term literature. So we shall have the topic here, literature. So we shall begin by defining the term literature. And we are saying literature is any form of art that is mostly written down and is of superior quality. And this art uses language in a special way. Now that's literature. So if you look at our definition, we are talking about the word art. The word art means it's creativity, relies on creativity, relies on imagination. In other words, someone has to think and come up with something that may not be existing. That is art. And this art is mostly written down. Why is it written down? For the purpose of future generations. If you have this art and it's not captured in a book, we might easily lose it. And that's why we write, that's why it's normally in books, so that we can keep it for future generation, what we call prosperity. And then we are also saying that this art is of superior quality. That means not just any piece of writing is considered as being literature. It must be of superior quality, must be of high standard, so that it can withstand the test of time. And lastly, this art uses language in a special way. In a special way. We are going to look at literature in details. We actually deploy language in a special way. So that is literature. I want to give a very good example. There's a book known as Romeo and Juliet. Who wrote it? It's called William Shakespeare. That book, students, was written about 500 years ago. But up to today, the book is still relevant. If I read by so many people, because that book in itself is a masterpiece, is of superior quality, and the language used is used in a special way. So that is literature. So that's the definition of the term literature. And then literature has two broad categories. So we have what we call genres or categories of literature. And students, we have two main categories of literature. Number one is what we call written literature. And number two, oral literature. Now in this lesson, we shall look at written literature. We have already done oral literature in details in previous lessons. So we want to begin looking at written literature. We said oral literature is literature that is handed down, that is conveyed through word of mouth, from one generation to another generation through word of mouth. Unlike written literature, which is actually conveyed through the written word. By this I mean it's actually documented in books. So that's what we mean by the word written literature. So we're going to look at written literature in details. So we're going to have written literature. And I've already defined the creative work of art. Whose medium of exchange is through the written word. Is through the written word. And employs language creatively. So this is how we define written literature. The creative work of art whose medium of exchange is through the written word and employs language creatively. So we want to look at the various, before we look at the various genres of literature, we want to look at features of written literature. So we shall look at features of written literature. And students, we want to look at features of written literature. And I have to mention this, that these features also apply in oral literature. The difference is the medium of communication. In oral literature, I said, you're using word of mouth to convey the message. But in written literature, we're using the written word. So the first feature is it uses language creatively. By this I mean language must be used in a special way. We're going to look at that. We're going to apply some stylistic devices in language use. So in written literature, we use language in a way that is very special. Number two, it carries a moral lesson. Yes, students, any piece of creative work, any piece of literature that does not support morality is not deemed as literature. Even if that work is creative, but does not support morality, or in other words, supports immorality, then that is not written literature. Number three, it is fictitious or fictional. I'll explain. The word fictitious means what actually happens in that story is not the reality. It's actually out of sheer imagination. Therefore, the characters in that story are not your real characters in real life. They are actually made by the writer. We call that fictitious or fictional. Literature also reflects what happens in the society. As much as the characters in that book in that book are fictitious, but the message that they espouse, that they bring forth, should be what happens in the society. In fact, we say literature is a mirror of the society. Literature should show, should mirror, should reflect what happens in the society. So students, these are the major features of literature, both oral and written literature. Now, I now want to look at the forms of written literature. Forms means the various categories, the various types of written literature. And the first one is poetry. Number 2 is drama. And number 3 is prose. Now let me explain each one of them, students. Poetry is the study of poems. We are going to look at those poems in details later. But when you study a poem, we call that poetry. Drama is the study of plays. When a play is a book. Once you have this play on stage being acted, we call that drama. The study of plays is called drama. Then we have prose. Prose is the study of continuous writing. That means when you are writing, for example, a novel, you write in lines, then you go to paragraphs. You write in sentences, and then you go to paragraphs. We call that prose. So students, we shall look at each one of these in details. But for today, we want to look at prose writing. So we're going to have prose. And I've said prose is the study of continuous writing beginning with a sentence which builds into a paragraph, then we have it builds further into a page. So that is prose writing. You start with a sentence. Then you have a number of sentences that will build into a paragraph. And then that paragraph will then build further into a page. And then from a page, you're going to have a chapter and all that. So we call that prose writing. And so under this, we want to look at forms of prose writing, what we call categories of prose writing. Or forms of prose writing. The first form is what we call the novel. The novel, I'm sure students, at one point you have read a novel either in a primary school or in secondary school. So what's a novel? A novel is just a form of continuous writing that is long. It's called a full-length form of continuous writing. So this is a full length form of continuous writing that is complex in character building and it addresses a wide array of what you call of issues, which you call themes. So a novel is just a book, a story that is long, maybe 100 pages, 200 pages, that's a novel. For example, The River Between by Ngugi wa Thiong'o is a well-known novel, and there are many more novels. Now, for you students, we have what we call set books. Set books. Set books are texts that have been given by the government that you need to study either in Form 3, that you need to study in Form 3 and in Form 4. And they are going to run from 2019 to 2023. So from 2019, we are going to have new set books. Those which have been existing, now that time has elapsed. So we're going to have new set books that are being rolled out, that are going to be studied by students. Now in this category of the novel, this is now your new set book. Blossoms of the Savannah. This is the new set book by Henry Olekulet. So students, this is the first compulsory book that you are going to study, and it is a novel. Something else, as you buy this book, students, get a book that has been approved by the Ministry of Education. We normally have various versions of books, but get a book that has been approved by the Ministry of Education, what we call a school version. The second book is called The Pearl by John Steinbeck. Now, this is a novel, but this novel is optional. Optional. The first one is compulsory. This means all students in this country, in Kenya, will have to study Blossoms of the Savannah. This novel, The Pearl, is optional. That means you can decide to study it or not. So students, the novel is the commonest form of prose writing. Let us look at other types of forms of prose writing. Now, stemming from the novel, and now this is number 2. Number 1 was novel. These are the set books that are under the novel. Number 2, we have what we call a novella. 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 Now, a novella is a short novel. This is a short novel. For example, students, if you decide to write a book that is about 50 pages or 70 pages, a novel in that case, then that novel is not complete, is not a full-length novel. We call that a novella. it is a short novel. But novellas are very rare in writing. Number 3, we have short story. Now, a short story is close to a novella, only that a short story is shorter than a novella. Any piece of writing, any prose writing that is between 3 pages and 20 pages, that is a short story. So, a story that can be read in one sitting is called a short story. A story that can be read in one sitting. It can be between 1,000 to 7,000 words. So that is a short story, students. And for our set text, what normally happens is we are given a collection of short stories. So for the year 2019 to 2023, these are the books that we are going to study. It's called Memories We Lost, and Other Stories. They have been edited by Wanjala Chris. So students, now this title is an anthology. It means a collection, anthology. It means a collection of many short stories. One of them is Memories We Lost. So this is a set text that you are going to study from 2019 all the way to 2023. It's called the short story. We have these stories. The editor is Chris Wanjala. He's the one who compiled those stories, Chris Wanjala. Number 4, students, is what called an autobiography. Remember, we are still looking at prose writing. We said number 1 is novel, number 2 is novella, number 3 is short story, number 4 is autobiography. An autobiography is a story about a person's life written by himself or herself. So a story about a person's life written by himself or herself. For example, students, if I write my life history, my life story, from the time I was born to where I am right now, I'm the writer, I'm the author of that book, it's about me, then that is an autobiography. They are very common. Most leaders actually normally write their own autobiographies. Number 5 is biography. Now, a biography, just like an autobiography, talks about someone's life story. The difference is who is writing this story. Biography, someone else writes your life story. Get me clearly, students. In an autobiography, you write your own story. You are the author of your story. So it's about you. So it starts by looking at your life from the time you are born. You say, I was born on this day. But in a biography story, someone else writes your story. So there's someone who's going to study your life and is going to pen down your life history. That is a biography. A story about a person's life written by somebody else. So that is a biography. Let us now look at other forms of prose writing, and I'll come this side. So our number 6 is called historical fiction. Now remember we said that literature is fictitious. That means what actually is in that book is not in the real life. For example, if you meet a character in a certain book, that character does not necessarily exist in the real life. But in historical fiction, we are capturing history as it happened. So in this book, we have facts and not fiction. So it's a story that captures historical events. Therefore, it is factual. It is factual. Now, most writers like blending, like mixing fiction with fact, with the history. So you'll find in most stories, for example, in the river between, you find there's fiction, the story of Wayaki, but there's also the story of Kenya, how Kenya gained independence. That is fact. So the writer is going to blend, is going to mix fiction with fact. So a story that entirely talks about historical matters or issues, that is a historical fiction story. Then we can even have science fiction. Now, in science fiction, the writer will talk about the scientific aspect, mostly about the future. So a story that captures the likely future scientific events is called science fiction. Some of us may have read stories about the outer space, Mars, Jupiter. If, for example, a story is set on another planet, like Mars, Jupiter, a story is set in the outer space, that is science fiction. It's not about what's happening here and now, it's about the world of science. That is called science fiction. Then lastly, how about realistic fiction. Now, I've talked about the science fiction, setting a story in the scientific world. But some stories actually talk about what's happening in the real world. So when a writer captures what happens, so it's a story story that captures what happens in the real world or realistic world. In this case, you capture what is happening here and now, what people go through, our daily struggles. Such a story is called a realistic fiction. So, students, this marks the summary. This marks actually the end of today's lesson. And before we finish, I want to give you a recap of what we have talked about. We began by defining the term literature, and you say that any creative work that is artistic in nature and uses language in a special way is called literature. And in most cases, literature is in written form. Then we said there are three main categories of written literature. There's poetry, there's drama and prose, and of course there's oral literature that I said we had covered earlier. So under written literature, we have poetry, we have drama and prose. And we have said that poetry is the study of poems, either writing or a poem written by somebody else. Once you study it, you call that poetry. Drama is the study of plays, and our plays normally acted on a stage. So we call that drama. Prose, what we have discussed majorly, is the study of continuous writing. And in this case, we said from a sentence, you build to a paragraph, then you build into a page, and then you build into a chapter. That's prose writing. Then under prose writing, we have various forms of prose writing. We have the novel, that's the commonest form of prose writing. We have the novella, which is a short novel. We have a short story. We have an autobiography. We have a biography. We have historical fiction, science fiction, and lastly, we have the realistic fiction. So up to that point, students, that will mark the end of today's lesson. Until next time, be blessed. Thank you.
CPE students can now access top-notch lecturers anytime from anywhere. Download CPE video lectures from www.manifestedpublishers.com.
Here's how to access the video lectures. 1. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full names, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account. Proceed by clicking on Confirm button. Your account is ready for use and you can watch some free sample videos before you purchase.
Disclose.
To get access to the complete videos, use the following steps to buy. 1. Click on View All Courses. Select the course you want to buy. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on the cart or total amount and click on Check Out Now to proceed. Click on Lipa na M-Pesa and proceed to pay. Go to M-Pesa on your phone, select Lipa na M-Pesa, then the pay bill option. Enter business number 796533. Enter the account number provided. Enter the total amount, not less or more. Enter your M-Pesa PIN and send. You will receive a confirmation SMS from M-Pesa with a confirmation code. Thereafter, you will receive an email confirming receipt. To access your lessons, place your cursor on your name, then click on Subscriptions.
Hello viewers, welcome once again to our probability class. Like I told you, this is a topic in Form 3 and so far we have done almost all of the subunits what we are doing is that now we are looking at further exercises in what we are calling tree diagram. We are looking at further exercises in tree diagram. So this probability, and we are looking at tree diagram. Now, my name as your host is Geoffrey Omondi, and I hope we learn together. Now, in the last class in tree diagram, I gave you a number of exercises. There's an assignment I gave. So assignment from last class. So there's an assignment I gave, and that was exercise from KLB, exercise 13.4. I gave you number 1 all the way to number 6. So I want us to try a few of them so that you can see what you did from the last class. So I want us to try number 2, and it is important I write that question so that we are able to follow it from the write-up I will be able to give from this place. Now, the question was, so I'm reading from number 2, KLB, that is page 261. The probability of a horse, A, the probability of it should be the probability that horse A, so this is not of, but that. So the probability that horse A wins a race against horse B is 2/5. If the horse runs 3 races in succession, if the horse runs 3 races in succession, find the probability. Find the probability that horse A, so we can give them the first one. Horse B wins all the races. Horse B wins all the races. Question B, horse A wins only 1 race. Horse A wins only 1 race. C, horse A wins at least 1 race. Horse A wins at least 1 race. D, horse B wins more than horse A. Horse B wins more races than horse B. So those are the questions we are dealing with. The probability that horse A wins a race against horse B is 2/5. If horse A runs 3 races in succession, find the probability that horse B wins all the races. Horse A wins only 1 race. Horse A wins at least 1 race. host B wins more races than host B. So when you look at this, especially in the first race, you realize immediately we are talking of mutually exclusive events, meaning that both horses cannot win the race at the same time. If horse A wins, horse B must lose. And if horse B wins, horse A must lose. And we say that when you're talking of mutually exclusive events, then the total probability is always certain, and it is 1. So the chance of horse A or horse B winning is actually 1. Now, I want us to try and draw that tree diagram together. Now, I want us to talk of horse A winning or horse B winning. So the chance of horse A winning, we are being told horse A wins is 2/5, 2/5, 2/5, 2/5. Now, these are mutually exclusive events. It means that their sum should therefore be 1. So if horse A is dealing with the 2/5, it means that we need 1 minus 2/5 to get the chance for horse B. And therefore, we will have 3/5, such that 2/5 plus 3/5 is 1. Mutually exclusive events. So that is the first race. Now, if horse A wins the first race, we can have a second race where we'll have horse A, horse B. Or if horse B wins the first race, we'll still have a second race, horse A winning or horse B winning. Now, the chances don't change. So in this case, horse A winning again will be 2/5, horse B winning 3/5, horse A winning 2/5, horse B 3/5. And we can create a third. Now, this is the second race. First race, second race, and now we are coming up with a third race. So in the third race, we'll again have AB, 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 and lastly AB, like that. So again here we'll have 2/5 for A and 3/5 for B. We'll have 2/5 for A and 3/5 for B. We'll have 2/5 for A in that instance and 3/5 for B. 2/5 for A and 3/5 for B. So from there, the most important thing now is to come up with what we call the outcomes. The outcomes. So to see this probably very well, I can use a different ink that will be able to give us. So this will be horse A winning, and horse A winning. That means that horse A is winning all the races. Or we can have horse A, then horse B. So horse A winning the first race, horse A winning the second race, then horse B winning the third race. Or we can have horse A winning the first, horse B the second, horse A the third. So that one will be horse A, horse B, horse A. Or we can have horse A winning the first, horse B winning the second and the third. So that will be horse A, horse B, horse B. Or we can have horse B winning the first, horse A winning the second, and horse A winning the third. So that will be B, A. Or we can have horse B, horse A, horse B. So that will be B, A, B. Or we can have horse B winning the first and the second race, and horse A winning the third race. So that will be B, B, A. Or finally, we can have horse B winning all the races, which is B, B, B. So once you draw this, actually you've come up with what we call a tree diagram. Now, normally, even if you're not asked to draw, this will attract some marks, about 2 points, 2 marks for you having to come up with this. Because this is very important, and almost all the responses we are going to give in successive questions depend on whether you are able to draw this tree diagram correctly. So if you come up with the wrong diagram at this point, then it's almost going to be impossible for you to get this responses correct. So I want us to start with the first one. Find the probability that OS B wins all the races. So this will be the probability that OS B wins the first race and wins the second and wins the third, like that. Probability of OS B, B, B. So when we look at that, we know that silently there are multiplication signs in between. That is what we know. This is actually how it should be written, but this is what we write, B, B, B. So in that instance, therefore, the probability of getting the first B is 3 out of 5, times the second B is 3 out of 5, times the third B there is 3 out of 5. Now, I'm using this branch because this is the only branch that gives us an outcome of B, 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 B winning all the races. So from that point, we can go ahead and say that this will be 3 times 3 times 3, giving us 27, over 5 times 5 times 5, giving us 125. So that becomes the probability of OS B winning all the races. Now, the second part B, find the probability of OS A winning only one race. Now, you therefore have to come to the outcomes here and look at a situation where we only have A winning one race. So starting with the first one here, we have A winning all the races. Here we have A winning 2 races and B winning 1. Here we have A winning 2 and B 1. In this instance, we have A winning 1 and B 2. So this is one of the outcomes we need. Here we have B winning 1, A winning 2. Here we have B winning 2, A winning 1. So this is another response we need. And lastly, here we have B winning 2 and A winning 1. This is another response we need. So when you look at all these responses, here the outcomes, when you look at all these outcomes, you realize that A is only winning once, which is what we need here, A winning once. So we'll start with the first one here, probability of A winning the first race, followed by B winning the successive 2 races. So we'll say it will be the probability of A followed by B, B, or this other one here, which is the probability of B followed by A followed by B, or the last one, probability of B followed by B followed by A, like that. So that is what we need. So from this instance, we can look at the probability of A, which is actually probability of A, which is actually 2 over 5, times the probability of B, which is 3 out of 5, times probability of B, 3 out of 5, or means plus the probability of B, which is 3 out of 5, the probability of A, which is 2 out of 5, and the probability of B, which is 3 out of 5. Or, and or here actually means plus. The probability of B, which is 3 out of 5, multiplied by probability of B, 3 out of 5, multiplied by the probability of A, which is 2 out of 5. So we can continue and shift that information here. Now, working with the 2 over 5, 3 over 5, and 3 over 5, we can solve this by saying 2 times 3, that is 6, and 6 times 3 is actually 18. So this one will give us 18 out of 125 plus, now, if you're keen, you'll immediately notice that the values that are being multiplied in each of these 3 brackets are similar, meaning the value answer you get for the first bracket is actually similar for all the 3. So this will also be 18 out of 125 plus finally 18 out of 125. So bringing that information up, we agreed that if the numerator If the denominator are similar, then you simply add the numerators in case of addition of fractions. So the response of that will be 18 plus 18 plus 18, giving us 54, over only one of the denominators, which is 125. At this instance, I don't think there's a common divisor for the two, so that will become our answer for OS A winning only one race. So we can look at part C. OS A wins at least one race. Now, again, we have to come back to our tree diagram, where OS A wins at least one race. Now, what that means is that OS A will win 1 or 2 or 3 races. So, what does that mean? Now, when you look at this place, OS A wins at least one, you'll realize that in the first instance, OS A is winning at least one because it's winning 3. He's present here, he's present here, he's present here. OS A is still present, OS A is here, and OS A is here. So the only place where OS A doesn't win at least a race is a situation where OS B has won all the races, which is OS B, B, B. Now, we agreed that these are mutually exclusive events. In other words, if we were to add all these outcomes, our answer is 1. So looking at this, and we know that where OS A is winning at least one race is all these values except B, 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 we can therefore say that the probability of OS A winning at least one match, one race, that is, at least one race can be given by 1 minus the probability of OS B winning all the races, like that. So in this instance, therefore, we'll have 1 minus. Now, remember, we had already calculated OS B winning all the races, and our value was 27 out of 125. So that will be giving us 27 out of 125. Now, if we subtract this, therefore, our answer will actually be 98 out of 125. 98 out of 125. Those who are not very conversant with this, we will take LCM here, 125. Then 1 will go into 125 times 1. That will give us 125 minus. 1 will go into 125 once times 27, which is 27. 125 minus 27 is 98 out of 125. So that is how we've come with that value. So we can look at the last one. OS B wins more races than OS B wins more races. This should have been OS. Let me just check it to be clear. So OS B wins more races than OS A. OS B wins more races than OS A. So again, we'll come back to our tree diagram and find those instances where OS B has 2 or more. So when you look at this case, OS A has 1 more, OS A has 1 more, OS A has 1 more, OS B has 1 more here. So this is important, we pick it. OS A has 1 more, OS B has 1 more again, so we pick it. OS B has 1 more, so we pick it. And OS B has also 1 more. So from that instance, therefore, we can see what we need. So that is D. So that would be the probability of, the first instance is OS A, OS B, OS B. Or the probability of OS B, OS A, OS B. Or the probability of OS B, OS B, OS A, OS B, OS B, OS A, or the probability of OS B, all of it, the probability of OS B, which is probability of OS B, OS B, OS B. Now, there's something I want us to realize here immediately as we work on this. The probability of OS A winning more is the same as the probability of OS A winning only one race or no race at all. That is the same as the probability of OS A winning only one race or no race at all. Now, the probability, so we can say this is the same as the probability of OS A winning one race, or the probability of, so this is OS A, or the probability of OS A winning no race. So when we say probability of OS A winning one race, or the probability of OS A winning no race. So probability of OS A winning only one race, we worked it here, which gives us now 54 out of 125, or plus probability of OS A winning no race. Now, when you look at our tree diagram, the only instance where OS A is winning no race is actually where OS B is winning all the races. So that is similar to the probability of OS B winning all the races here. So, of course, you can see that OS B winning all the races, that was the first instance, is actually 27 out of 125. So when you work this one out, you get 81 out of 125. Now, there's something I want us to see, other than what I've just shown you here. We were able to come up with this probability very well. I want us to see that this probability you are seeing here and here, at this particular point like this, probability of ABB or BAB or BBA, you can clearly see it here. So we have to be keen when we are working so that we don't work twice. Now you realize that these questions can be very long in their responses. So you have to be keen to notice what you've already calculated so that you don't calculate it again. Again, probability of BBB, you are able to see that it is something we have already worked on here. So you simply pick those values and put it here. Now it is allowed. Once you've already calculated a value and you've been marked for it as correct, it is allowed you can pick that value and continue working with it without having to rework again every single value. So I want us to look at the next. I want us to look at next part of the assignment you are given. So that was number 2. I want us to straight away try number 6, which is also an assignment that was given to you in the last class. Number 6. I want us to try number 6. Now the question in number 6 was, a man playing a game of darts, has a probability of a third of hitting a double. Has a probability of a third of hitting a double. If he throws 3 darts, if he throws 3 darts, find the probability of him hitting. Find the probability of him hitting A, 2 doubles, B, more than one double. More than one double. And C, at least two doubles. At least two doubles. So I want us to try that and see. So we will clean here so that we can try that. Now I want us to be clear that once the questions involving a tree diagram, the key is the diagram itself. If you have the diagram correct, normally you find it very easy to work with that diagram. So I want us to draw the diagram. So a man is playing a game of darts and is throwing 3 darts. So I want us to see the probability. So let the probability of hitting double be represented by H, and not hitting, in other words missing, be represented by H naught. This is read as H naught. So we are talking of this H and H naught. So let us look at the first throw. So the first throw, we can have a hit or no hit, H naught. So we can also have a second throw with a hit or no hit. Third throw, hit, no hit. Hit, no hit, like that. Here, if the first one was no hit, the second can be hit or no hit. The third here can be hit or no hit. Hit or no hit. Now, we are told that to hit is a third, meaning if this is mutually exclusive, to not hit should be 2/3. So to hit is a third. Not hit, therefore, should be 2/3. So that if you add a third to 2/3, you get 1. So we will have a third and 2/3, a third, 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 2/3, like that. So those are the probabilities. So it is important, therefore, that we get the outcomes. Now, remember I told you earlier that this tree diagram will earn you points because it's a very important part of marking your work. So if you draw it correct, it becomes very easy for you to answer what is required from you, and you will be rewarded for drawing it. There will be a point. So this one, the first outcome here will be hit, hit, hit. So H, H, H. Hit, hit, not it. So H, H, H naught. Or hit, no it, hit. So it will be H, H naught, H. Or hit, not hit, not hit. So this will be H, H naught, H naught, or no it, hit, hit. So this will be H naught, H, H, or no hit, hit, no hit. So H naught, H, H naught, or no hit, no hit, hit. So this will be H naught, H naught, H, or no hit, no hit, no hit. So H naught, H naught, H. So those are the possible outcomes that we can have. So actually this is the sample space. This is what we are referring to as the sample space. of this throwing of dart in 3 successions. So we can continue from there. And now using that tree diagram, we want to try and answer the questions that follow. So what is the probability that he hits 2 doubles? So this is A. So we are looking at a probability that we have 2 out of 3 hits. Remember, this particular player or man has thrown this dart 3 times. So if we ask what's the probability of 2 doubles, we are actually looking at probability of 2 hits. So if there are 3, only 1 should not be a hit. So we are looking at a situation where we have 1 hit not and 2 hits. So in the first case, we have all hits. Those are all doubles, 3 doubles. In the second instance, we have hit, hit, not hit. So these are 2 doubles. So this is one of the things we need. Here, we have a double, no double. So this is another thing we need. Here, we have 2 not hits, and therefore we don't need it. Here, we have 2 hits. Yes, it is another instance we need. Here, 2 not hits, we don't need it. 2 not hits, we don't need it. And here, everything was miss, not it, that way. So we are looking at those 3 instances. So we can come and say we are looking at the probability of, the first one is hit, hit, no hit. Hit, hit, no hit, like that. Or the probability of hit, no hit, hit. Hit, no hit, hit. Or the probability of the last one, no hit, hit, hit. No hit, hit, hit. Yeah, so those are the probabilities that we need from that point. Now, from here we can now work on them. The probability of hit, hit, not hit. Now, the probability of hit we have agreed is a third, and not hit is 2/3. So in this case, the probability of hit will be a third times the probability of another hit is a third times the probability of no hit is 2/3. Or means plus, and therefore probability of a hit here will be a third, no hit 2/3, hit a third. Or, which is again plus, the probability of no hit here is 2/3, hit a third, another hit a third. So these are the probabilities we are talking about. So from this instance here, we can now multiply and say we will now have 1 times 1 times 2, which is 2 out of 3 times 3 times 3, 27, plus the numerator is 2, denominator is 27, plus 2/27, giving us a total of 2 plus 2, 4 plus 2, 6 out of 27. Now we can simplify this further by knowing that 3 can cancel here twice, and 3 goes into 27 9 times. So that will give us 2 out of 9. So we can also look at more than one double, number B. So number B, we are talking of more than one double. In other words, you are looking at one double, or we are looking at 2 doubles or more doubles. So it will be 2 hit, we are looking at 2 hit, that is 2 doubles, or 3 doubles to give us more than one double. So when we are looking at 2 doubles, we already have that, so that would be the probability of 2 doubles, or the probability of 3 doubles. Now, when we look at this, the probability of 2 doubles, we already have it in part A, and it's given by 2/9, or is plus probability of 3 doubles, meaning that is hit, 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 which can be given in this place like that. So that will be the probability of 3 doubles, hit, like that. So from here, we can still work it out and find this 2 out of 9 plus a hit was a third, the probability of another hit a third, and probability of the third hit is also a third. So working with this, we can therefore have 2 out of 9 plus a third times a third times a third, which gives us 1 out of 27. So we can get LCM here, which is actually 27. 9 would go into 27 3 times. 3 times 2 would be 6, plus 27 into itself once. 1 times 1 is 1, giving us a probability of 7 out of 27. So this is a way in which you can be able to do it. So we can look at number C. Can look at number C. Allow me to do it here. Create a space here so that we are able to do it. We can work on it neatly like that. So this will be C. Now in C, we are looking at least 2 doubles. At least 2 doubles. At least 2 doubles. Now, when you say at least 2 doubles, it means that you are talking of 2 or more doubles. You are talking of 2 or more doubles. In other words, this means 2 or more doubles. But when you look at that keenly, it can also mean more than 1 double, because more than 1 double is actually 2 or more doubles. Now, when you are able to look at all this, what does it bring us back to? It means that at least 2 doubles is the same as more than 1 double. And therefore, in that instance, we've already calculated more than 1 double, and therefore our response is simply 7 out of 27. So I want us to stop there for this class today. Meanwhile, I want to add you more assignment which you can try, and we can see if we can work them out in successive classes. I want to give you an assignment, and we'll see if we will be able to work them out in successive classes. In your assignment, please work on number. So this will be exercise. This will be exercise 13.4. You'll be able to work on number 9, number 10, number 11, number 12, number 13, number 14. Number 10, number 11, number 12, number 13, and number 14. Now, I want to appeal to you. Some of the times we can leave an assignment like this and you find you are not able to do it. Please feel free to go to the comment section just below this video and put your comment asking a question so that we can give you guidance on what is supposed to be done. You can also confirm with us and we give you a response. We can give you a worked example in the comment section so that you are able to work it out and follow what we have done. Otherwise, for now, I want to say goodbye. I was your host, Geoffrey Omondi. Have a nice time till we meet again.
Hello learner, my name is Dickens Mugalo, and today we want to talk about salts. Let's start by looking at the objectives. At the end of this topic, you should be able to define a salt. Then number 2, you should be able to state and describe types of salts. You are going to see we have around 4 types of salts. And then number 3, you should be able to identify both soluble and insoluble salts. Then number 4, by the end of this topic, you should be able to state methods of preparing both soluble and insoluble salts. And then number 5, you should be able to define the terms saturated solution, crystallization, neutralization, as well as precipitation. And then number 6, you should be able to write ionic equations. We shall see we are going to write ionic equations using precipitation reactions. And then number 7, you should be able to state the effect of heat on salts. We shall see salts behave differently when they are decomposed by heat. And then lastly, by the end of this topic, you should be able to state uses of salts. Having said that, let us start by knowing the meaning of the word salt. So, Lana, what is the meaning of this word salt? So, a salt can be defined as follows. So, a salt can be defined as a compound that is formed when hydrogen ions from an acid are wholly or partially replaced by a positive ion. For example, if you look at this equation here, if you react, for example, a zinc metal with hydrochloric acid, you'll realize that zinc will react and the product will be zinc chloride and hydrogen gas. So, Lana, we are saying that this hydrogen ion in the acid has been replaced by the positive ion, and the positive ion is zinc. As a result, the product formed is called zinc chloride, and this zinc chloride is what we are calling a salt. So, from the definition, we are saying a salt is a compound formed when this hydrogen ion from the acid is replaced by this positive ion or a metal. So, as a result, the product that we are forming is called zinc chloride, and that is our salt. So, let's now move on by looking at types of salt. So, we have said a salt is defined as a compound formed when hydrogen ions from an acid are wholly or partially replaced by a positive ion. So a positive ion is also called a cation, which can be a metal, like for example, the example we have used above there. So next up is I want us to look at types of salts. Let's look at types of salts. We have 4 types of salts, like I've said earlier. So types of salts. So we start by mentioning them. So the first type we call acid salt. Then number 2, we have normal salt. Then number 3, we have a basic salt. And then number 4, we have a double salt. So Lana, we are saying we have 4 types of salts, namely acid, normal, basic, and double salt. So let us see what is the meaning of each type of salt. So we are going to start with an acid salt. So what is the meaning of the word acid salt? So an acid salt, from the word acid, in Form 1 we learned about acids and said all acids contain a hydrogen ion. So we are saying the distinguishing property of an acid salt is what? All acid salts, their distinction property is that all of them contain a replaceable hydrogen ion. So how do we identify an acid salt? An acid salt is identified by the presence of hydrogen ion. So we are saying an acid salt can be defined as a salt that contains a replaceable hydrogen ion. So let's look at examples. For example, we have a salt such as sodium hydrogen carbonate. From the formula, Lana, we can see that we have a hydrogen ion. So this hydrogen ion is the one that will make this salt to be called an acid salt, because it has this hydrogen ion that will give it the acidic properties. We have another example is sodium hydrogen sulfate. So this hydrogen ion that is present in this salt is the one that will give it the acidic property. So we are saying, Lana, that an acid salt is one that contains a replaceable hydrogen ion. As you can see from these two examples, we have a hydrogen ion in the sodium hydrogen sulfate, as well as a hydrogen ion in the sodium hydrogen carbonate. Therefore, these two, we call them acid salts. The second type of salt is called a normal salt. So, Lana, we are saying, so the second type of salt, we're calling it a normal salt. So, Lana, what is the meaning of the word normal salt? So, a normal salt, the definition can be obtained from the definition of an acid salt. So, such type of salts, Lana, we are saying, these ones do not contain a replaceable hydrogen ion. So, what are they? So, we are saying a normal salt can be defined as a salt that does not contain a replaceable hydrogen ion. So we call it a normal salt. So it's the one that does not contain a replaceable hydrogen ion. So let's give examples. So the first example is called, let me write the name, sodium carbonate. Sodium carbonate. This is how we write sodium carbonate. Na2CO3. So as you can see from this formula, student, we are saying this salt does not have a hydrogen ion, and therefore we call it a normal salt. Example 2, we have sodium sulfate. Sodium sulfate, the formula Na2SO4. As you can see from the formula, the compound does not have any hydrogen ion. As a result, we call it a normal salt. So we are saying, what is a normal salt? A normal salt is the salt that does not contain a replaceable hydrogen ion. So we have these two examples, sodium carbonate and sodium sulfate. So our next type of salt, we are saying we have a basic salt. So that's number 3, basic salt. So in Form 1, we learned about bases, and we said bases. How do you identify bases? All bases are identified by the presence of hydroxide ion. So for that reason, when you're defining a basic salt, it means a basic salt is the one that contains a replaceable hydroxide ion. So we are saying, what is a basic salt? So a basic salt is a salt that contains hydroxide ions. Of course, the formula is that. So basic salts are identified by the presence of hydroxide ions. So what about examples? So the first example, we are saying, e.g., we have basic zinc chloride. Basic zinc chloride, this is the formula. We have ZnOH and then Cl. So now we are saying this salt is called a basic salt because of the presence of hydroxide ions. Another example is basic magnesium what? Chloride. So the formula is MgOH then Cl. So we are saying this one is also classified as a basic salt because of the presence of hydroxide ion. So we are saying a basic salt is identified by the presence of hydroxide ions. The third type of salt, we are calling it a double salt. A double salt, so this is a new term we are encountering today. So a double salt is defined as a salt that contains two different cations or anions. So earlier on we defined a cation as a positively charged ion, whereas an ion is defined as a negatively charged ion. So we are saying a double salt is the one that will contain either two different cations or two different anions. So the two cations or anions should be different. So therefore we shall call it a double salt. So an example is trona. Trona, this is how we write trona, is a mixture of sodium carbonate with some sodium hydrogen carbonate and some molecules of water. That's an example of a double salt. So why are we calling it a double salt? Because it has a carbonate, which is a radical, and that radical is negatively charged. As a result, it is an ion, and then it also contains hydrogen carbonate. So this carbonate and this hydrogen carbonate are different. Are different what? Anions. Therefore, we classify this as an example of a double salt because it has a carbonate which is different from hydrogen carbonate, and the two are found in the same salt. Another example is ferrous ammonium sulfate. This is the formula for ferrous ammonium. Is a mixture of ammonium sulfate and iron 2 sulfate. So this is how we write it: FeSO4 Of course, sulfate has a valency of 2 with some 6 molecules of water. So, Lana, we are saying this salt is classified as a double salt. Why? From the definition, it has this cation, that is iron 2. It also contains ammonium. So, this one is a positive ion, and we know positive ions are called cations. This one is another positive ion, which is called ammonium ion. So, the two are different, and the two are found in the same salt. So, therefore, this salt is classified as a double salt. So, we are saying that we have 4 types of salts. We have acid salt, we have normal salt, we have basic salt, and we have a double salt. So we have defined each as what? Just a quick recap of that. We have said an acid salt is identified by the presence of hydrogen ions. We have said a normal salt, the definition can be gotten from the definition of an acid salt, which we have said a normal salt is defined as a salt that does not contain a hydrogen ion. And then we have said a basic salt is identified by the presence of hydroxide ions. And then lastly, we have said a double salt is the one that contains 2 different what? Cations or anions. So we have come to the end of our lesson. Let's, I want you to try these questions. So the first question I want you to try is, I want you to try and define the meaning of the word salt. And then number 2, giving examples, define the types of salts. So try those 2. And I believe you should be able to answer. So we have come to the end of our lesson. I want to thank you for being a good student. I'll see you in the next lesson.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. Welcome to today's biology lesson. Our topic of discussion is sexual reproduction in plants. And today we are continuing our study on pollination. So today we are going to look at the second agent of pollination, and that is wind. So we are going to look at adaptations of wind pollinated flowers. And these wind-pollinated flowers are also known as anemophilous. flowers. So in this case, we are saying that these flowers have special adaptations that enable wind to be an agent, to be an effective agent of pollination. Now, one of the adaptations is that these flowers are small in size, whereby petals may be or may not be absent. There are flowers that are very inconspicuous. You cannot easily notice them. And these are the flowers, for example, that we find in the grass family. Yeah? If you look at the flowers in grass, they are very, very small. Their petals are very small and very inconspicuous. You cannot easily notice them. So we are saying that flowers are small with small and inconspicuous petals or bracts or inflorescence. So these flowers may exist, some as petals, some as bracts, some as inflorescence that are small and inconspicuous. So they are not very easy to identify. Now, another feature is that since these flowers do not need to attract the wind, because the wind will just come about, they have no nectar and are not scented. They are not scented. And therefore, they do not need to attract the agent of pollination. Which in this case is wind. The other characteristic or the other adaptation is in their anthers. Their anthers are large. And loosely attached to a flexible filament. They are large and loosely attached to a flexible filament to allow them to be swayed by wind. So their anthers are large, loosely attached to a flexible filament so that they are easily swayed by the wind, so that the wind can collect the pollen grains. Swayed by the wind to collect pollen. How are the pollen grains themselves? The pollen grains are small. They are small, light, and many. To allow them float in air during transportation. To allow them to float in air during transportation. That's why they need to be very light, very small, and many, because some of them will be lost along the way. The stigma is also large feathery, or sticky to collect pollen grains, floating in the air. So their stigma are large, they are feathery, or some of them are sticky, so that once the pollen grains touch them or get into contact with them, they will just stick, so that now pollination will be enhanced. So basically, those are some of the adaptations that are commonly found in wind pollinated flowers, also known as anemophilous flowers. The other thing that we are going to learn are the features and mechanisms that hinder self-pollination and self-fertilization. The features and mechanisms that hinder self-pollination and self-fertilization. So what happens here? There are some features that exist naturally to ensure that self-pollination does not take place. And if self-pollination does not take place, then self-fertilization cannot take place. Which are these features? Now, one of those features are the hermaphrodites and monoecious plants. Hermaphrodites are those flowers that have both sexes. And monoecious plants are those plants that have flowers having both sexes. So these hermaphrodites and the monoecious plants, they have some natural features such as the scent, bright color, large petals, conspicuous petals. So those natural features ensure that self-pollination does not take place because they encourage cross-pollination. They encourage insects to come and act as an agent of pollination. So in other words, we are saying that they encourage cross-pollination. So we are saying that they have features such as brightly colored petals, and conspicuous petals. They are scented to attract insects and hence encourage cross-pollination. So we are saying that those features, they encourage cross-pollination at the expense of self-pollination. So in the process, they hinder self-pollination. So the fact that they are able to attract insects by their brightly colored petals, conspicuous petals, and their scent, and also even the nectar, you'll find that they will encourage more cross-pollination than self-pollination. Number two is what we call self-sterility or incompatibility. Self-sterility or incompatibility. This is whereby when the pollen grains land on the stigma within the same plant, they cannot germinate pollen tubes. They cannot germinate pollen tubes because they are similar. They are genetically identical to the other parts of that plant. So they are generally incompatible with the stigma of the same plant. And therefore, they will not germinate pollen tubes, and therefore there will be no self-pollination. So self-sterility, we are saying that pollen grains are sterile, i.e. cannot germinate pollen tubes on the stigma of the same plant. So this discourages self-pollination. And encourages cross-pollination. So basically what we have learned today, we have learned the adaptations of wind-pollinated flowers, what we also refer to as anemophilous flowers. The adaptations are, their flowers are small, very small and inconspicuous petals or bracts or inflorescence. They have no nectar and also are not scented because they don't need to attract anything as an agent of pollination. The wind is usually there most of the time. Their anthers are large and loosely packed or loosely attached to a flexible filament, a filament that is very flexible to allow them to be swayed by the wind so that the wind can be able to obtain the pollen. The pollen grains themselves are light, very light. They are small in size. They are many so that they can float in the air during transportation. The stigma is large, feathery or sticky so that the pollen grains can stick. Those pollen grains that are floating in the air, once they come into contact with the stigma, they will just get attracted. You can also mention here that that the stigma hangs outside the petals. Of course, that is to also encourage the collection of pollen. We've also learnt about the features and mechanisms that hinder self-pollination and self-fertilization, the factors that ensure that self-pollination and self-fertilization does not take place. We've seen hermaphrodites and monoecious plants, and these ones, they have special features that encourage cross-pollination. Brightly colored and conspicuous petals, the fact that they have nectar and they are scented encourages cross-pollination. Number two, we've seen self-sterility or incompatibility, whereby the pollen grains are sterile to the stigma of the same plant, and therefore it cannot germinate the pollen tubes. So we are going to stop there, and we'll have a short assignment on what we have learned. So the assignment for today, the first question, state and explain 5 adaptations of wind-pollinated flowers. Number 2, state and explain 2 features that hinder self-pollination and self-fertilization. So we're going to meet next time. Goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. We are continuing with the topic on sexual reproduction in plants, and basically we are on pollination. My name is Stephen Kariungi, and we'll continue from where we left last time. So today we will look at 2 more factors that hinder self-pollination and self-fertilization. So last time we discussed hermaphrodites and monoecious plants, how they discourage self-pollination. We also discussed self-sterility or incompatibility. So today we are going to introduce some 2 additional factors, and that is number 3, protandry and protogyny, and another one more factor. Now, first of all, it's important to understand the meaning of those 2 terms, protandry and protogyny. Protandry, andry comes from the word androecium, or the male parts of the flower, which we saw earlier. Now, protandry is whereby the male parts of the flower, which are the anthers, they ripen and produce pollen grains before the stigma is ready to receive those pollen grains. So, even if those pollen grains are transferred onto the stigma, they cannot germinate pollen tubes. So, there won't be any self-pollination. On the other hand, protogyny, gyne comes from the word gynoecium, and this is whereby the female reproductive parts mature faster or mature earlier than the male reproductive parts. So the ovary is mature, it has produced the female gametes, and it is ready for fertilization. But the anthers have not yet matured to produce the pollen grains. So in this case, we refer to that as protandry and protogyny. So we'll explain the 2 terms. So you can say that protandry the anthers ripen earlier and produce pollen grains before the stigma is mature to receive them. We also have protogyny. Is where the stigma is mature to receive pollen grains, but the anthers have not ripened. To produce pollen grains. So we refer to that condition as protandry and protogyny. So we say that protandry, the anthers are ripe. They ripen earlier. And they also produce the pollen grains. But the stigma is not yet mature to receive them. On the other hand, protogyny is where the stigma is mature to receive the pollen grains, but the anthers have not ripened to produce those pollen grains. So a combination of the two enhances the fact that self-pollination cannot take place. And if self-pollination cannot take place, self-fertilization can also not take place. The other factor is a factor known as heterostyle. Now, in this factor, heterostyle means that the stigma and the anthers are positioned in such a way that one is higher than the other. They have different arrangements, such that it is not possible for the pollen grains to land on the stigma of the same plant or of the same flower. So we are saying that this refers to different arrangements of stigma and style to discourage pollen grains from landing on the stigma. We'll have an illustration of that. So in this case, the anthers are at a lower position. Than the stigma. So the pollen grains may not be able to land on the stigma that is up here. So this indicates heterostyle, which is the different arrangement so it therefore discourages self-pollination from taking place. So basically, we have seen those two factors, protandry and protogyny. We have also seen heterostyle as the two other factors that discourage self-pollination and therefore self-fertilization. So our assignment So the first question, explain how heterostyle discourages self-pollination in plants. We have explained there. So you will go through the notes, understand them, and then be able to answer the questions that have been stated. Question number 2, what is the meaning of the term protogyny and the term protandry? We have mentioned the two terms as other factors that hinder self-pollination and self-fertilization. So we are going to stop there. Goodbye. See you next time.
Welcome to Manifested Publishers.
Hi, my lovely learners. I am so excited to have you again on this platform. Remember, this is Manifested e-learning platform and I am Teacher Purity. So we are going to learn hygiene and nutrition activities for grade 3 and we are starting on a new topic about the use of improvised materials for cleaning utensils. Under the use of improvised materials for cleaning utensils, we shall start by learning the types of dirt that are found on utensils. So, welcome to the lesson and hope that you are going to enjoy. Now, types of dirt that are found on utensils. Utensils are the things we use at home to serve and cook food. So remember, when you cook from a sufuria and also serve your food from a plate, they get dirty. So we want to see the types of dirt that are found on utensils. Now we clean utensils at home to keep away germs. Germs can cause diseases and can make us to fall sick. So we clean utensils at home. So we clean utensils at home to keep away germs. Remember, germs are not good for our health. When you serve your food from a dirty plate, you can become sick. We also wash utensils or clean utensils at home to keep away pests such as cockroaches. We clean utensils to keep away cockroaches. We clean utensils to keep away cockroaches. Dirty utensils attract cockroaches. No, so now that is the reason why we clean utensils at home. First, to keep away germs, and second, to keep away pests like cockroaches. So what are some of the types of dirt that are found on utensils? So types of dirt. The first type of dirt that found on utensils, we can have milk dirt. Milk dirt is the first one. Now milk dirt includes the dirt, maybe that a cup that you've used to drink your tea or even yogurt. So milk dirt is a type of dirt found on utensils. Then we have another one, we call it grease dirt. Now grease dirt includes dirt that has come from oily foods like meat or fish or eggs. So grease dirt looks oily. Then we have the last one, we call it starch dirt. Starch dirt. Starch dirt is the remains of food that remain on a plate. We call them starch dirt. So these are the main types of dirt that are found on utensils. The first one is a milk dirt. Now this is an example of milk dirt. This cup was used to drink tea and therefore there are remains of the tea. So this one is milk dirt. Then we have grease dirt. Grease dirt is the dirt that remains on plates or utensils that you've used either to serve meat or fish or eggs. Then we have lastly starch dirt. So starch dirt is the remains of food that remain on a plate after you've eaten. So this is an example of starch dirt. Can see there are remains of food on the plate. We call them starch dirt. So these are the main three types of dirt that are found on utensils. The first one, we have milk dirt. Then we have grease dirt, and lastly, starch dirt. Milk dirt is when you have used a utensil to serve milky foods. Then grease dirt is the remains of oily foods like the fish, fried eggs, or meat. And lastly, we have starch that. These are the main types of utensils that are found, that are found on utensils at home. And we are supposed to clean our utensils every day. Remember to keep away germs and also to keep away pests like cockroaches. So back at home, I want you to visit your kitchen, check where the dirty utensils have been placed, and try to identify the 3 types of dirt: the milk dirt, grease dirt, and starch dirt. Meanwhile, I'll give you some work for you to copy. Get ready with your exercise book, pencil, and rubber. The question: write down 3 types of dirt found on utensils. You will write the 3 types of dirt found on utensils. Fill your answers in blank space number 1, 2, and 3. Then make sure that you are going through your work after you have completed it. So hope to see you in the next lesson, and thank you for attending the lesson.
Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Hello students, welcome to Manifested e-learning platform. My name is Wilson Andove. I'm your literature teacher. In the previous lesson, we began talking about aspects of poetry, and the dominant one was rhyme. And we said that rhyme is the matching of sounds at the end of lines. So before we go into today's lesson, I want us to have a brief recap of what we talked about rhyme. We said that rhyme is the matching. This is the matching of sounds at the end of words in a line in a poem. That is rhyme. And I want to give just an example of what I gave you in the previous lesson. There's this short poem. Now, to demonstrate rhyme, I want us to recap this poem that we had looked at in the previous lesson. We said we are looking at the end of lines. We are looking at the last word at the end of the line, in a line. So the word that we are looking at is reeds. It runs through the reeds, and away it proceeds through meadows and glade, in sun and in shade. So in rhyme, we look at these words. So the word reed and proceeds, they have the same sound. So these are rhyming words. Reeds and proceeds are rhyming words. So are glade and shade. So we call this end rhyme. End rhyme, because it's coming at the end of a line. You can see reeds and proceeds. These words are rhyming, but they're coming at the end of lines. Glade and shade are also rhyming words, but they're coming at the end of the line. So we call this end, meaning rhyming words come at the end of a line. Okay? Now, in today's lesson, I want us to look at another form of rhyme that we call internal rhyme. Internal rhyme. Now, just like end rhyme, where sounds match, in internal rhyme, we'll find that a word that is in the middle of a line will match with a word, will match with a sound that is at the end of the line. So in internal rhyme, we find that sounds match. Sounds which are in the middle of a line will match with the sounds at the end of a line. So we say the matching of sounds that are in the middle of a line with those at the end of a line. So that is internal rhyme. The sounds at the middle of a line and at the end of the same line are matching. We call that internal rhyme. And I want us to look at an example of internal rhyme. And here is a poem. Here is a poem entitled The Raven by Edgar Poe. I said in the previous lesson that the writer of a poem is called a poet. So in this case, Edgar Poe is the poet, the writer of this poem, The Raven. So the poem says, the sheep was cheered, the harbour cleared, and every day for food or play, in mist or cloud, or mast or shroud, while all the night through the smoke white, the fair breeze blew, the white foam flew. Now I want us to look at this poem while we are matching sounds. In this case, we're going to look at the sounds, we're going to look at the words at the end of lines. So we're going to look at these words which are coming at the end of lines and the sounds at somewhere in the middle of the line. So I'll go through the poem again slowly. The ship was cheered, the harbour cleared. Now in the first line, you can get the fact that the word cheered and cleared have the same sound. So cheered and cleared are rhyming words. It's only that cheered is coming somewhere in the middle of the line. It's not coming at the end. So the ship was cheered, the harbour cleared. So cheered and cleared are rhyming words. But this word comes somewhere in the middle of the line. So we call this internal rhyme. Look at the second line. And every day for food or play. And every day for food or play. So the word day and the word play are rhyming. Get the sound A and A. Day and play, the rhyming words. In mist or cloud, on mast or shroud. Cloud and shroud. So you also get this sound out. Cloud, shroud. So these two words, cloud and shroud, are rhyming words. While all the night through the smoke white. So night and white. You hear the sound night, it, white, it. So the word night and white are rhyming words. The fair breeze blew while the white foam flew. So again, blew and flew. These two words have the same sound. So students, if you look at this poem, you can see words which are rhyming. The only difference is some words are somewhere in the middle of the line. So the word day and play are rhyme. Only that day is somewhere in the middle of the line and play comes at the end of the line. So we call this internal rhyme. So we shall say internal rhyming words, and they are cheered and cleared, we have day and play, we have cloud and shroud, then you have night and white, and lastly blue and blue. I hope that concept is understood. I'll just re-emphasize that internal rhyme, just like end rhyme, you'll find that a word that is used somewhere within a sentence, in most cases at the middle of the sentence, rhymes with a word that is coming at the end of that particular sentence, as we have seen these examples given here. So these are rhyming words, but you call these internal rhyming words. Unlike the end rhyme, whereby we only find rhyming words at the end of the lines. So I hope that is very clear. Now, students, I want to look at some other aspects of poetry, and we want to look at something called alliteration. Alliteration, and this is the repetition of consonant sounds at the beginning of words in the same line in a poem. The repetition of consonant sounds at the beginning of words in the same line in a poem. Now, students, I want to give an example of a tongue twister. Look at this tongue twister. If can tie a tie. Now, this is what we are talking about. We are talking about we are repeating consonant sounds. In this line, we have the following consonant sounds. We have ka, ta, and ta. Remember, students, we are talking about consonant sounds, not spelling. So, for example, can tie, this ka and the word can, both of them have the ka sound. The ka sound. So we say the word can tie and can are alliterating. I repeat, the word can tie and can are alliterating because both of them have sound ka, and I said it's about the sound, not the spelling. Please, students, be very careful because some of us look at the spelling and we are saying it's about the sound, not the spelling. If can tie a tie. So we call this alliteration. Another example. Peter bought a pack. A pack of, let us have another one. Bitter butter. Peter bought bitter butter. Now, if you look at this sentence or this statement, you can see we have pa, sound pa, as in the word Peter. We have ba, as in the word bought. We have ba in bitter and then butter. So, in this line, we have this sound ba, ba, ba. These sounds have been repeated. Bought, bitter, butter, ba, 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 ba sound. So we call this alliteration. We are repeating the sound ba, and we say it at the beginning of words in the same line. So we call that alliteration, okay? Now, another example, another style we call assonance. Now, unlike alliteration, where we're repeating consonant sounds, in assonance we are repeating vowel sounds. So this is the repetition of vowel sounds in words in a poem. We are repeating vowel sounds in words in a poem. For example, kill and bill, kill and bill, will and bill, for example. If you look at these words, kill and bill, we have E, will and bill. So when you are repeating vowel sounds, A, E, this sound E, kill and bill, will and bill. So when you repeat such sounds, we call this assonance. Now please note, in assonance we are repeating vowel sounds in the same line in a poem. For example, kill and bill, will and bill, we are repeating the sound E. So we call this assonance. You need to underline it. Now we look at other styles which are common in poetry, other terms, sorry. The other term that is used in poetry is dialogue. Now, a dialogue is a conversation. This is a conversation between two or more characters in a poem. So, in a poem, if you find two or more characters speaking, we call that dialogue. As long as you have two or more characters speaking, converse, we call that dialogue. Another feature that you need to know is called setting. The word setting means the place and time. The place and time when the actions in a poem take place. So it means the place and time when the action in a poem takes place. So if you are asked, what the setting of this poem? It means where. A poem can be set maybe in a classroom, can be set in a forest, can be set near a river, can be set in a church or a place of worship. So it means the place, and also time. Can be in the morning, late at night, or even a season. So we call that setting. Another common style is called simile. Simile. I'm sure while you were in primary school you had similes like, you are told as fast as a cheetah. You have heard of such statements. As slow as a chameleon. As brave as a lion. So those are similes. So a simile, this is a statement that compares two things or people using the words like or as. For example, you say Jane, example, Jane is as fast as a cheetah. So we are comparing Jane with a cheetah. Jane is as fast as a cheetah. So we are comparing Jane. The speed of Jane is like that of a cheetah. So we call this a simile. He is as brave as a lion. Again, you can see we are comparing this person. He's brave like a lion. So we're comparing those two aspects. So we call this a simile. And you can have many more. I wanted to give other similes that you may know of. Related to the simile, students, it's another term that you call a metaphor. So you have a metaphor. Now, a metaphor is just like a simile, only that does not use the word as or like. So it compares a statement that compares two people or things without using the word like or as. Like or as. For example, if we say Jane is a cheetah. Jane is a cheetah. What does it mean? Does it mean that Jane is an animal? No, it doesn't. It means that Jane runs as fast as a cheetah. So this is a metaphor. James is a lion. Does it mean that James is an animal? No, it means that James is a brave man, just like a lion. So, words which compares two things directly, such statements without using the word as, they are called metaphors, and they are very common in poetry. So you should be able to get more examples. You can say, she is a bee. What does it mean? It means that she is a busy person. She's not an animal. So you should be able to identify use of similes and metaphors in poetry. Then, so students, before we finish, I want us to have a brief recap of what you have learned today. Today we have talked majorly about poetry and some other styles, but we said when you're dealing with rhyme, we have two types of rhyme. We have end rhyme and internal rhyme. End rhyme comes at the end of words, whereby you find that some words are matching. We call that end rhyme. But internal rhyme is whereby we find sounds which are somewhere in the middle of a sentence and that at the end of the sentence are matching. These are very good example: cleared and cheered and cleared, day and play. So we call that internal rhyme. We have gone ahead and talked about some other styles used in poetry, like dialogue, and we said these are convenient between two people. We have talked about setting, which means the place and time when an action in a poem takes place. We have also talked about similes and metaphors. Up to that, student, that will mark the end of today's lesson. Until next time, God bless you. Thank you.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Checkout Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Welcome to Manifested Publishers.
Hello, Lana. Welcome to our manifested online learning. We are going to have a lesson in history and government. We are studying the topic European invasion of Africa and the process of colonization. That is the topic that we have been studying. It's a Form 3 topic, the first topic of Form 3 work. We have been looking at studying the subtopic, the African reaction to European colonization. We said the Africans reacted to the process of colonization in two ways. The first way was what, my dear Lana? What did we say were the reactions of the Africans? Very good, resistance, and then collaboration. So we are continuing with our series on the collaboration. I said we are going to look at two communities in Africa that collaborated with the European powers. That is the Baganda, who are in East Africa, and also the Lozi, who are found in Southern Africa. So in our previous lesson, my dear Lana, we looked at the terms that were made by the Buganda during the Buganda Agreement that was made in 1900, and we said it was made between the British and the Baganda people. Each had representatives, and they made elaborate terms explaining their relationship. We divided those terms into terms concerning the boundary, terms concerning the government, terms concerning the economy or the finances or revenue of the kingdom. And then lastly, we looked at, I said we have looked at the boundaries, we have looked at the government, and then we have looked at the revenue or the monies that they had. That is the public revenue. And then we also had, finally, we had land, concerning land ownership. So number one, there is government. Then number two, there was land ownership. And then there was finances or the sharing of revenue. And then lastly, there was what else? I've mentioned land, there was government, there was finances, and then the boundaries. Very good. So today we are going to look at the results. In our lesson today, we are going to look at the results. The results. I'm going to look at the results. Let me get a pen and write the results. The results of the Buganda collaboration. The results of the Buganda collaboration. What were the impacts? What were the consequences of the Buganda collaborating with the British? So quickly let us look at them. The first one was it led to economic development. It led to economic development. There was the building of schools. Building of schools, which led to increase of knowledge, which in return helped them make good development. There was also building of roads and access ways. So these resulted to economic development. That is the first result. And then number two, the position Kabaka retained his position. Actually, with the coming of the British, Kabaka was referred to as His Highness. His Highness. So his esteem or his prestige was further improved with the coming of the British. So he was more respected because he was recognized. Even the British recognized his position because they cemented his position as the king or the leader of the land. And then there was spread of Christianity. There was spread of Christianity. My dear Lana, the British were Christians. So as they came to lead, they introduced Christianity. They built mission stations. Mission stations where there were churches, where the people were converted. Most of the people of the Buganda kingdom were converted into Christianity. They were forced to abandon their traditional beliefs in they desired or they preferred to be Christians because the Baganda or the white people, the British, seemed to be more advanced. So they desired or they opted to have Christianity as their religion. And then apart from that, they got protection. They got protection against enemies. They got protection against enemies. One of their biggest enemies was the Bunyoro people or the Bunyoro kingdom. The other one was Khedive of Egypt. So the British were able to protect them or give them protection from the British or from these enemies that were attacking or were bringing or were against the Baganda. Also, there was decline. There was decline in Islamic influence. There was decline in Islamic influence. So with the coming of Christianity, the Islamic religion that had been brought as a result of the long distance trade, He was the kingdom now was a Christian kingdom. Christianity had taken a bigger portion. So the Islamic religion had been reduced. So they could not have as bigger influence as the British with their Christianity. And then there was improvement of trade links. So Uganda was exposed to the outside world. Uganda was exposed to the outside world. They got Western goods. Western goods. Some of these goods include, they had glassware. There was glassware. There were weapons that they used to fight against their enemies. We have discussed that. They were able to get clothing, right? So this was a positive impact. They were able to get these goods that initially they were not able to have. And then we have a negative impact. They lost there was loss of independence. So the Buganda kingdom was declared a British protectorate, or land belonging to the British. So the people of Buganda no longer had a say. They no longer had a direction of their own. So they had to be subjected to the rule of the British. Also, the Kabaka's power. Kabaka's power was reduced. Initially, Kabaka would decide on every matter of the community or of the kingdom. But now, with the coming of the British, his powers were reduced. Everything he had to be confined. Remember when we were talking of the agreement, when you are looking at the government, they agreed that every decision had to be in confines of the protectorate government. If the decision the Kabaka was going to make was against in any way the British protectorate, that brought a problem. So Kabaka's power, the absolute power, you remember in your Form 2, we mentioned that Kabaka was considered to be semi-divine. He was almost a god. Whatever he said was revered, or whatever he said was followed. But that power, that absolute power that he had, was now checked by the British. So those are some of the results. I'm sure, my dear Lana, you are able to get more results of the collaboration of the Baganda. So you could go and get more. You can do more research. You can go to your textbook, your KLB textbook. You can get an Evolving World textbook. You will be able to get more results. These are just a few that we have mentioned in our lesson today. So as we end our lesson today, my dear learner, I want you to attempt this revision question. Attempt this revision question as we end. Revision question. Revision question to help you look at what you have studied today. Discuss the positive. Discuss the positive effects of the Baganda collaboration. Discuss the positive effects of the Baganda collaboration. And with that, my dear learner, we have come to the end of our lesson, our history lesson today, and I hope you have enjoyed the lesson. Until our next time, it's bye-bye.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello and welcome back, learners. This lesson is a continuation of the lesson that we had last time, where we were discussing the environmental, the external environmental factors that affect businesses, and we discuss the competitors, customers, suppliers, political factors, legal factors. Then at the end of that lesson, I gave you the assignment. You're supposed to explain explain the 3 ways in which competition may affect a business. 2, discuss how political factors may influence the operations of a business. It's my hope that the assignment is done. This was assignment for the last lesson, and the topic is business and its environment. The subtopic is external environment. This lesson is a continuation of that lesson. So I want to discuss the other factors, external environmental factors. So the 6th factor is the economic factors. Economic factors. Economic factors. Economic factors. Now, these are factors that influence the entire economy of a country. A business will need to monitor trends in the economy, as changes may affect its operations. For example, changes in the level of prices in the economy, the changes in interest rates, the changes in inflation, okay? All this will affect the cost of products and also the cost of doing business. So performance of the economy, learners, and stability of the currency will always affect the price of goods and services that consumers are willing to buy and able to buy. Okay? Therefore, the changes in the needs and wants of consumers and the level of incomes of consumers will plays a very big role in determining the operations of the business, because we are saying the changes in inflation and so on will affect again the behavior of consumers depending on the incomes of the consumers. So business activities in an economy may also be affected by the availability of such projects or infrastructure that is put in place by the government. Okay, business activities in the economy may be affected by government investments in projects like roads, railways, communication, and so on. Because the government, at a general level, the government may build roads, may build railway systems and communication systems that will have an impact on business activities. Learners, again, the government on national level may build roads, railway lines, communication systems. That is now looking at the economy in general or at a national level. When the government does that, then that will have a positive effect on business
activities. So when you are running a business, it's important to look at the general economic environment. The general economic environment. We've mentioned the interest rates, inflation rates, and the incomes of customers or consumers, and government expenditure on projects like roads, projects like railway, projects like communication systems, and so on. So that again, all that is what we are referring to as economic factors. Economic factors. These are economic factors. Then we have social-cultural factors. Social-cultural factors. Social-cultural factors. Social-cultural factors. Social-cultural factors. These are factors that are based on people's beliefs, people's values, attitudes, opinions, lifestyles, and so on. And they may be determined by culture. These factors may be determined by the culture of the people, religion, level of education, age, ethnic background, and so on. So if these factors change, okay, then people's tastes and preferences may also change. All right. For example, people in, say, rural areas may start to have the same taste in clothing as those in big towns due to the influence of urbanization. Okay, influence of urbanization. When I was growing up as a young man, we're talking about clothing. There are some clothes that were not worn in the villages. Today, due to urbanization, people wear clothes that are worn in urban centers. Okay, so that is change. We are talking about change. So if you are in business of offering clothes, so and there is demand for these clothes that are worn in urban areas, in rural areas, then you see you also need to change, okay, so that you don't supply clothes that are no longer worn in the villages. So we are saying if these factors change, if the tastes and preferences of consumers change, then the business has also to change so as to meet the new needs of the customers. So learners, these are socio-cultural factors. Socio-cultural factors. Socio-cultural, this is one word. Social-cultural factors. These are factors that are based on beliefs, values, attitudes, opinions, and lifestyles of the people. And they are determined by culture. Culture means the way we do things, okay? They are also determined by religion. These social-cultural factors can also be determined by education. There's a way in which education shapes people to behave in a certain way. The social-cultural factors may also be affected by age. We've mentioned ethnic background and so on. So we said if these factors change, then people's tastes and preferences will also change. Preferences means what people prefer in terms of goods and services. If you're offering goods that people are no longer buying, then it means the preferences have changed. So we say that if people's preferences change, then you need to also change the products that you produce and services. So, but you cannot change if you are not monitoring the environment, if you are not checking to see what is happening in the external environment. You need to remember we talked about research and development in our previous lessons. You need to do market research. Continuously scan the environment to see if there are any changes so that you can also adjust to meet customers' needs. To meet customers' needs. These are sociocultural factors. Another factor, learners, is technological factors. Technological factors. Technological factors. Technological factors. What is technology? Technology is the application of scientific knowledge in performing work. It is the application of scientific knowledge in performing work. So a business has to consider the technological factors influencing its operations. If you are in education industry, you need to check what are the new technologies arising in that industry. If you are in manufacturing, you need to check what are some of the new machines or methods that are being used in manufacturing products. This is because technology can radically change the way goods are produced and services are provided. For example, the advent of the internet and the new gadgets, the mobile phones, the applications, and so on, such changes have radically revolutionized the way we do things, the way we offer our services, the way we offer products, and so on. At the same time, this technology can lead to reduction in costs and improved goods and services. So technological developments can lead to creation of new markets through adoption of what we call e-commerce, electronic commerce. And this allows businesses to operate without borders, right? E-commerce allows people to transact online. Today, a buyer in Kenya can purchase goods in US and make payment instantly. And that is what we are referring to as e-commerce. So this allows business to operate without borders. Without borders. Businesses, including individuals, are able to buy or sell goods and services over the internet. Over the internet. Even yourself, we are reaching you through the internet. Okay? I no longer need to come to your house to do physical tuition. Why? Because of the internet. You can now get my services while seated at the comfort of your home. So a business should take advantage of the technological developments that may improve its operations. And I think that's what manifested publishers are doing. They're able to prepare the products so that they can reach people over the internet. So that's technological factors. There's a lot that we can say about technology and how and why a business should scan the external environment to determine to understand how it operates, to determine the emerging technologies that will help the business to offer different goods or to improve the service delivery and to improve the existing products. So the adoption of technology may bring with it problems, learners. However, the adoption of technology may bring with it problems like disruptions brought about by breakdown of equipment, mass layoffs. Those are problems. and mass layoffs of staff due to lack of necessary skills, okay, and so on. We have certain in other countries where staff are being laid off because robots are performing tasks that were initially performed by people. So those are some of the adverse effects of technologies. But a business, when running a business, is important for the business owners to scan the technological environment. I've explained reasons why that should happen. Then lastly, we want to discuss the physical factors. Physical factors. Physical factors. Physical factors. This is the last factor. Physical factors. What are these physical factors? Physical factors. Learners, the operations of certain businesses are heavily affected by what exists in nature. For example, businesses dealing in agricultural produce depend heavily on the existence of appropriate weather and climate. So an unexpected change in these natural conditions may negatively affect the business. That is the climate, okay, the weather, and so on. For example, harvesting of tea, coffee, maize, and so on in Kenya are greatly affected by what we call incidents of frosts, which damage tea and coffee plantations. So some governments may also, other than these factors, the government may also pass protective laws that limit the availability or the availability of these resources, or the ability of businesses to exploit natural resources such as minerals, forests, and so on. The government can put laws in place that limit logging, cutting of trees, or exploiting certain natural resources. So if you are in an industry where you depend highly on natural resources like trees as a source of raw material, you see that again will affect, negatively affect the business. So such laws are aimed at protecting natural resources. When the government puts in place such laws, the purpose is to protect natural resources and the inhabitants of surrounding areas. Okay, so but businesses that face such restrictions would find it very difficult to remain in operation. So you see, this is an external environmental factor which the business may not have control over. When the government passes law, then you have no option but to obey. The government says there is no mining in certain area, then you can't mine because of the government's interest is to protect, in such a matter, is to protect such resources. So these are physical factors. I've mentioned the weather, I've mentioned the climate, and so on. Climates are not constant. They do change because of certain factors like global warming and so on. So those are physical factors. So learners, we have